NASA finds evidence of 10 new Earth-sized planets in our corner of the galaxy. The more we look, the more we find planets as small as ours. NASA has found new evidence of 219 planets outside our solar system. 10 of those exoplanets appear to be similar to the size of the Earth and orbit their stars in the habitable zone. How about that? Just far enough away to develop water, but not so far that they freeze. Well, see, my whole argument that we had to have come from a brown or red dwarf is the very fact that we have atmosphere. Because I don't think a stone going around the sun in the habitable zone would have anything to do with whether it had atmosphere or water. The moon pretty much proves that. It's been going around the sun for almost as long, if not as long as the Earth. It still doesn't have an atmosphere. That had to come about from some kind of an umbilical cord or connection, for lack of a better word, if you know what I mean. Or a natural process. It wouldn't just start happening on a dead planet spontaneously. The potential discoveries are part of the final catalog of results being released from the first Kepler Space Telescope mission. Kepler has been surveying the Cygnus constellation since 2009. During that time, scientists have found more than 5,000 potential exoplanets in an area of the sky about 3,000 light years away from Earth. Today's announcement whittled those candidates down to 4,034. A total of 2,335 of those have been verified as exoplanets, 21 of which are Earth-sized and orbit in their star's habitable zone. Earth-sized planets are of particular interest because they can teach us about how our own planet formed, and because there's a small chance they could harbor life. Like I said, I don't think there's too many main sequence stars that just develop planets without some kind of an umbilical cord.
That's what
I think it's the red or brown dwarf, or both. The potential discoveries are part of the final catalog of results being released from the first Kepler. Kepler spots planets by looking for dips in the brightness of the stars they orbit. It must be pretty damn sensitive to be able to distinguish a dip, known as a transit. When the scientists see this happen, they then study each signal to confirm that it's coming from a planet passing in front of the star, and not some other anomaly that they've created.
Yeah, shut up.
If it is a planet, the Kepler data can be used to determine its mass, size, and orbital period, or how long it takes to go around the star. New Kepler planet candidates. To get these newly refined results, the team moved away from identifying each signal by hand, an inconsistent method, according to Susan Thompson, a Kepler research scientist for the SETI Institute. You'd walk in and you go, looks like a transit. Looks like a transit. Looks like a variable star. You know what I mean? It was like junk, variable star. Oh, planet. It would be like that. We stopped doing it that way, she said during a NASA podcast interview. So to fix this, the Kepler team simulated their own positive and false signals of planet transit and compared them to the actual data from the mission. This allowed the team to figure out where they might have overcounted or undercounted a particular type of planet. I mean, you gotta get it dead eye. The result is that this final catalog should be the most accurate ever released by the Kepler team, of course. NASA is getting better at identifying Earth-sized exoplanets in other ways, too. The team spent 5 years working with the operators of the ground-based Keck telescope in Hawaii to study 1,300 stars that hosted planets of these sizes. From that effort, they were able to surmise that Benjamin Fulton, the lead author of this study, called a major new division in the family tree of exoplanets. During a press conference about the news, he compared the identification of these new planet classes to the discovery that mammals and lizards are separate branches on the tree of life. The division now is between two categories: super-Earths or rocky planets, about 1.5 times the size of our own, and mini-Neptunes, glassy planets, more than 2.5 times Earth's size. Well, that's good news for the exploding planet hypothesis. That means Earth is going to be allowed to get a lot bigger if you have 2.5 times bigger. Their terms were already used, but were sometimes considered interchangeable. It's an important distinction to make because Neptune-sized planets are almost always inhospitable to life as we know it. Our result sharpens up the dividing line, but if they are so big, then they're not favorable for life, Fulton says. Our result sharpens up the dividing line. I see. Over like what size does life stop appearing on a planet? That's interesting. Let's see. Planetary. They still believe in the accretion fantasy. Better knowledge of how to find planets like our own will help scientists sift through this final catalog of data from Kepler's original mission. It will also allow scientists to write better lists of promising targets that more powerful telescopes can study in the future. With the final catalog of planetary candidates from Kepler's original mission released, I'd like to see that. I'm going to search for that. I'd like to check out some of the systems, maybe talk about them. NASA will now focus on the K2 mission, which began in 2014, which has found over 100 different exoplanets so far. Exoplanets are interesting, especially in other solar systems. Was started as a way to give. It will also allow scientists to write better lists of promising targets the more powerful telescopes can study in the future. The final catalog, planetary candidates from Kepler's original mission released, NASA will now focus on the K2 mission, which began in 2014. K2, which has found over 100 different exoplanets so far, started as a way to give the telescope a second life after Kepler suffered multiple mission-threatening technological setbacks. Two of the telescope's 4 reaction wheels failed, one in 2012 and one in 2013, and at least 3 are needed to properly aim the telescope. Luckily, team scientists devised a clever workaround by using the sun's pressure on the telescope solar panels as a stand-in for the broken wheel. How that worked out. Kepler can still hunt for planets, but photons from the sun don't generate as much force as a reaction wheel can. The limits of the K2 mission mean scientists have to go about their searches more methodically. It's akin to picking up leaves in your yard one by one instead of raking them all into a bag. The telescope will continue on with K2 until it runs out of fuel, likely sometime in 2018. Oh, so it's probably already out there just floating around dead now, I guess. This is the first I heard of it. When asked during the press conference how the team felt about Kepler's first mission coming to a close, Thompson explained that she sees it more as a new beginning. It's always a new beginning. Amazing things that Kepler has found. It has shown us these terrestrial worlds, and we still have all this work to do, to really understand how common Earths are in the galaxy. Yes, I know, they are very common. I heard something to the effect of there could be as many as 5 billion Earths in the Milky Way galaxy. That's a pretty impressive number. Saturn's Death Star moon might be hiding in an underground ocean. During a mission to discover whether or not Saturn's moon Mimas was geologically dead, researchers discovered something far more surprising. It's not like we haven't heard that a million times before. Compelling evidence of an underground ocean buried beneath the surface of the Death Star-like moon, Mimas. The researchers say it might be a stealth ocean world, a finding that, if verified, would further expand the number of potentially habitable places in our solar system. Icy moons with evidence of Subsurface oceans have gathered a lot of attention from scientists lately. The two best-known examples in our solar system are Saturn's Enceladus and Jupiter's Europa. Don't forget Ganymede, it's the only moon with a magnetosphere, are considered prime places to search for alien life. Enceladus, in particular, appears to have most of the ingredients needed to sustain life and its seawater, which spews out geysers near the moon's south pole. Now, what do you suppose it's going on that causes that? It has to be an electrical event. But while the surfaces of both Europa and Enceladus show signs of geologic activity, suggesting an internal heat source that allows liquid water to exist. Current. The surface of Mimas is heavily cratered from thunderbolts, leading Southwest Research Institute scientist Elisa Roden to suspect it was just a frozen block of ice. However, Roden now thinks Mimas' cratered-like appearance kept an ocean hidden in research published earlier this month in the journal Icarus. Roden and her colleague Matthew Walker of the Planetary Science Institute in Tucson, Arizona, show that tiny wobbles or librations in the moon's orbit detected by NASA's Cassini spacecraft can be explained by gravitational interactions with Saturn that produce enough heat to maintain a liquid ocean beneath a thick, icy shell. A model developed by the team suggested that icy shell is 14 to 20 miles thick. Findings suggest Mimas is a compelling target to further investigation. Roden said in a release, studying the moon's potential to support an ocean could help researchers understand the prevalence of ocean moons in even more distant and poorly explored locales like Uranus. Like Uranus. You know that. I hate to be a negative Nell. It's far better to light a candle than curse the darkness. But I'll just say this. After you really get into the research and use critical thinking, you find out mainstream cosmology has nothing. They have the wrong theory. All of their assumptions are stated as facts, but are just assumptions. They live out of touch with reality. They can't even come to grips due to their acute scotoma with the fact that they're practicing the wrong science. It's more like a religion of consensual science where everybody has to agree. It's not science. We need to change that, friends. I have an idea to market a t-shirt to go with the little play on Star Wars, The Force, May the Force be with you. Put something like Standard Model Big Bang Cosmology. And then either on the back or below it say, May the Farce be with you. Because that's exactly what it is. Earth's magnetic field is weakening, but it's not about to reverse. We owe our existence to the Earth's magnetic field, the invisible barrier that protects the planet from the harsh radiation of space. But this shield is far from static and tends to wane and even reverse at semi-regular intervals. With the magnetic field currently weakening, there's been a lot of talk in recent years that another flip might be imminent, but a new study has looked at the history of these events and found that a reversal probably isn't about to happen. I think it's reset itself a couple times, but the mainstreamers, they can't make up their minds. I'll continue. The cause for concern starts with what's known as the South Atlantic Anomaly. SAA. In this area, stretching across the Atlantic Ocean from Chile to Zimbabwe, the magnetic field is substantially weaker than elsewhere in the world. Ever since this region was discovered in 1958, it's been growing as part of an overall weakening of the entire magnetic field over the last few centuries. The end result of that trend appears to be the reversal of the poles. Historically, magnetic north and south switch places every 200 to 300,000 years, and we're actually well overdue for such an event. It's been about 780,000 years since the last one. Although doomsayers love to shout about how a pole reversal would rain down hellish amounts of radiation onto Earth. NASA says that our biggest concern would just be buying new compasses. But how likely is that scenario anyway? To find out, researchers from the University of Liverpool, home of the Beatles, GFZ, German Research Center
Du hast mich.
for Geosciences, and the University of Iceland looked to past fluctuations in the field. A weakening magnetic field doesn't always mean that the poles are about to reverse.
It could just be an earth fart.
More often, that's fluctuate. More often than not, the field recovered its original structure, and this waning, recovering event is known as geomagnetic excursion. There you see the fancy pictures. It's the fancy picture channel. The intensity of the Earth's magnetic field at the surface and the radial field of the cosmic microwave background. During the last two excursions, the Pelasgian top and Mono Lake bottom events, University of Liverpool. The researchers modeled the geomagnetic field between 30,000 and 50,000 years ago. Their aim was to examine the two most recent geomagnetic excursions. The Pelasgian, which occurred about 41,000 years ago, and the Mono Lake, which occurred about 34,000 years ago. Team found that the magnetic field at those times looked nothing like it does today, indicating that the current changes aren't rare signs of any impending excursion or reversal. Indicating that the current changes aren't warning signs of any impending excursion or reversal. Now that's interesting. 30 to 50,000 years ago, one says 41,000, 34. I'm thinking that, the Earth's magnetic field the Earth had to get magnetized. And Dr. Velikovsky claims in Earth in Upheaval that the rocks in certain mountainous regions are 100 times more magnetic than the Earth's field. And that kind of, to me, says that there was once a giant body charging the Earth. The only way it's going to go up is if it gets another one of them charging situations. So I don't think this planet was meant to go around a yellow dwarf, G-class star like the sun. It was meant to go around a brown or a red dwarf. That could explain why the insects are dying now, fish are dying in the millions. I don't know, but it's possible. With the cosmic rays coming in, the atmosphere could change, and next thing you know, phases out one kind of life and paves the way for the next. It's just some surmising from me. It's not a total stab in the dark. It kind of has reasoning. There has been speculation that we are about to experience a magnetic polar reversal or excursion, says Richard Holm, co-author of the study. However, by studying the two most recent excursion events, we show that neither bear resemblance to current changes in the geomagnetic field, and therefore it is probably unlikely that such an event is about to happen. Our research suggests instead that the current weakening field will recover without such an extreme event, and therefore is unlikely to reverse. Well, I don't know about recovering. I think the magnetic field of the Earth probably has a lot to do with the sun cycles. We shall soon see. But I suppose we'll get to thunderbolts in a bit here. To back up, the team also found two periods where the field structure was most similar to how it is today. 49,000 and 46,000 years ago. Okay. I assume they're going by the little readings in the rocks. The field at these times had anomalies similar to, but much stronger than, that over the South Atlantic today, and yet neither developed into anything. Studies of chlorine and beryllium isotopes indicate that more cosmic radiation was indeed reaching the surface 46,000 years ago. The results of, as well as other similar studies, should help allay any fears of an impending polar reversal. Not only is it not likely to happen anytime soon, but even if it did, we don't have anything to worry about because they say so. Cook says that the Earth will never turn over. It's impossible. That's just his opinion, but I like that. Thought of an Earth turning over. Didn't do much for me. Let's see. And this is from the National Academy of the Sciences. All right. And then let's take a look at Thunderbolts group. Ties that bind. Earth and the Sun are joined together. The 4 magnetospheric multiscale satellites, MMS, were launched March 12, 2015, on a mission to study the magnetic field around the Earth, especially what scientists like to call magnetic reconnection. Events, according to the theory, when magnetic field lines cross and reconnect through some unknown mechanism, they are supposed to detonate, releasing large quantities of heat, light, and electrical energy. The fatal flaws in magnetic reconnection theory are not the topic of this paper. Suffice to say that magnetic field lines are merely representations that are no more capable of detonation than lines of longitude are. The MMS piggybacks on the time mission that was launched in 2001. The thermosphere, ionosphere, mesosphere, energetics, and dynamics spacecraft is currently in orbit analyzing solar influences on the Earth, especially the mesosphere and lower thermosphere, ionosphere, a region near 60 to 180 kilometers in altitude. The highest levels of the atmosphere are not well understood, especially the thermosphere, where the sun's energy begins to interact with atmospheric particles. Just how this relationship works continues to be investigated. However, time detected a tenfold decline in the thermosphere's temperature since 2002. Time measured the amount of ultraviolet light from the sun, finding a significant decrease since the start of the solar minimum. The amount of infrared radiation emitted by nitric oxide molecules also declined, the sun implying that the upper atmosphere cooled over the course of solar minimum. Temperatures in the thermosphere are dependent on solar radiation. Extreme ultraviolet light is absorbed by the residual oxygen and becomes electrically charged with increasing molecular motion. Fast molecular motion is known as heat. So even though a household thermometer would register temperatures below zero in the thermosphere, it is considered hot, sometimes reaching over 1500 degrees Celsius during solar maximum. The MMS constellation, as well as others scheduled for launch before the end of the decade, the Geospace Electrodynamic Connections mission and the Magnetospheric Constellation missions, are part of a widespread international consortium known as Global Electric Circuit Project. We will do this through development of improved understanding and processes controlling the charge and discharge of electrified clouds, the electrical coupling between the atmosphere and ionosphere, and the flow of current throughout the system. The 22-year solar cycle is now known to energize Earth's climate. Earth's environment is part of a circuit in the solar system with the sun as the primary electrode, although the solar energy varies over time, corresponding with sunspot cycles. Well, you increase the electricity and you increase the magnetosphere. That variance amounts to less than 0.1%. Electricity from space is injected into the thermosphere from charged particles emitted by the sun, otherwise called solar wind, speeding along massive Birkeland currents through a closed circuit. When solar winds are at a minimum, the electric currents decline in amperage, thereby decreasing the strength of the Earth's magnetosphere. There you have it. It's controlled by the sun. As the magnetosphere declines in strength, it is less able to deflect energetic ions arriving from deep space, known as cosmic rays. Cosmic rays are charge carriers, and those ions are able to reach the troposphere. Collisions between charge and neutral particles drag air molecules along with them, influencing low-level cloud cover. More clouds reflect more radiation from the sun back to space. Clouds are white because they are acting like mirrors to all forms of visible light. More reflection means less solar energy, more cloud cover, and so on. Solar maximum is now considered to be over, and the sun is returning to a more passive state. Correspondence between the sun's electric field strength, cosmic rays, the Earth's magnetosphere, cloud cover, and climate are continuing to be investigated. Electric universe advocates expect further confirmation of the connection. Stephen Smith. Now in come the Electric Universe, the Thunderbolts group, to rain on the parade. Astronomers think FRBs are created from dying stars. About 8 years ago, astronomers discovered an energy signature they called a fast radio burst, or FRB. The blast of radio waves lasted 5 milliseconds, releasing more energy than the sun puts out in a month. Distance to the source was said to be almost 3 billion light years, and was surmised to come from the death of a black hole. Another source for FRB energy is thought to be from cosmic batteries. If a black hole orbits a neutron star, its immense gravity is thought to create the power that sends those strange bursts into space. Cosmologists recently advanced a theory that black holes can evaporate with surprising violence. If a black hole contains M solar masses, it will glow at 6 times 10 to the power of 8 M Kelvin. That means a black hole can eventually explode like a hydrogen bomb. It is those explosions that are supposed to generate radio emission. Recently, astronomers working with a combination of radio regarding optical telescopes announced that FRB 121102, the first repeating fast radio burst, exploded into space with the force of many supernovae. As the press release states, however, astronomers now have a new puzzle. The source of the broadcast is from a surprisingly small galaxy. Since the galaxy is puny, it is thought that the black hole physics must be involved with FRB formation. Black holes radiating away their masses does not conform to electric universe theory. Radio waves and range of energy curves are properties of lightning bolts. Computer simulations demonstrate that plasma phenomena are scalable over several orders of magnitude, so they behave in the same way whether in atoms or galaxies. Perhaps FRBs are really flashes of cosmic lightning erupting from electrified clouds of plasma on an immense scale. If correct, FRBs are most likely nearby, so they are less energetic. Plasma is the correct way to interpret their behavior, but it is exploding double layers that impel them. Rather than relying on mathematical phantoms like black holes in tandem with overweight neutron stars, why not create real testable hypotheses and work them up with real physical models? Plasma experiments in the laboratory correspond to plasma formations in space because of the scalability factor. Under similar conditions, plasma discharges produce the same formations independent of size. whether in the laboratory or on a planetary, stellar, or galactic level. Since duration is proportional to size, an electric spark that lasts for microseconds in the laboratory might last for years at the stellar scale, or millions of years at the galactic scale. Stephen Smith. Very good. And we have another one. Power in perspective. What astronomers call a fast radio burst can release more energy in 5 milliseconds than the sun does in 80 years. Assumed distances to such high energy sources is said to be 1 billion light years or more. Because of redshift measurements, if that is the case, then the power concentrated in those flashes of energy is equivalent to billions of hydrogen bombs. What could generate those forces? At the outset, it is important to consider that in an electric universe, radio waves and a range of energy curves are properties of lightning bolts. Computer simulations demonstrate that plasma phenomena are scalable over several orders of magnitude. They behave in the same way and illustrate basic premise whether in atoms or galaxies. Recently, physicists working with the Australian Square Kilometre Array Pathfinder announced the discovery of so many FRB sources that they effectively doubled the catalog listings, according to Dr. Jean-Pierre McCourt from the Center for Radio Astronomy Research. Bursts travel for billions of years, passing through intergalactic material along the way. Each time this happens, the different wavelengths that make up the burst are slowed by different amounts. Timing the arrival of the different wavelengths tells us how much material the burst has traveled through on its journey. Assumptions about distance and the density of matter in the universe are built on previous assumptions about the size of the universe and its age. Light waves traveling for billions of years through uncounted clouds of gas and dust betrays a factual presumption underlying all ideas about distance and conditions in the universe. Its size is based on Big Bang theory and black holes factor. And when FRB energies are discussed by the mainstream, collisions among black holes or the explosion of black holes are held forth as explanations for the energy signatures. However, laboratory experiments confirm that plasma formations in space can be modeled in the laboratory. Laboratory experiments confirm that plasma formations in space can be modeled in the laboratory due to their scalability. Under similar conditions, plasma discharges produce the same formations independent of size. Since duration is proportional to size, an electric spark that lasts for microseconds in a laboratory might last for years in the stellar scale or millions of years on the galactic scale, where they might suddenly erupt and then dim again. Electric universe cosmologists postulate that FRBs are actually occurring in nearby galactic neighborhoods, so they are not unimaginably powerful and not coming from the edge of the universe, as previously written. Plasma discharges in the form of exploding double layers can accelerate particles in ways that are unfamiliar to consensus astrophysicists. Consensus, that's interesting. Plasma physicist and Nobel laureate Dr. Hans Elfane thought that exploding double layers should be considered a new class of celestial object. Electricity is responsible for stellar and galactic behaviors, and when the current density gets too high, double layers in those circuits catastrophically release their excess energy, appearing as FRBs, X-rays, or flares of ultraviolet light. Elfane wrote, "A study of how a number of the most used textbooks in astrophysics treat important concepts like double layers,
critical velocity, pinch effects, and circuits is made. It is found that students using these textbooks remain essentially ignorant of even the existence of these, in spite of the fact that some of them have been well known for half a century, e.g., double layers, Langmuir, 1929 pinch effect, Bennett, 1934. If correct, FRBs are actually nearby, so are less energetic. Plasma is the correct way to interpret their behavior, but it is exploding double layers that impel them. Rather than relying on mathematical phantoms like black holes, why not create real testable hypotheses and work them up with real physical models? Perhaps FRBs are really flashes of cosmic lightning erupting from electrified clouds of plasma in an immense scale. Stephen Smith. Well, he goes more into depth here, but they're pretty much the same. But interesting. I mean, when you have to hypothesize gigantic black holes and neutron stars, you have to also hypothesize huge H-bombs blowing up millions of light years away.
Chapter 7. Deserts and Ocean. The Sahara. The Sahara Desert, which stretches from the Nile to the Atlantic Ocean, across the continent of Africa, and covers 3,500,000 square miles. About the area of all of Europe, is the greatest desert on Earth. What is now the Desert of Sahara was an open grassland, or steppe, in earlier days, drawing on rock of herds of cattle made by early dwellers in this region, were discovered by Barth in 1850. Since then, many more drawings have been found. The animals depicted no longer inhabit these regions, and many are generally extinct. It is asserted that the Sahara once had a large human population that lived in vast green forests and on fat pasture lands. Neolithic why do it half-assed when you've got the video here? So, just bear with me for 1 minute. And, I wanted to watch the one that's got Sewillic Hills in it. That is one of the weirdest mountain valleys in the world. They find bones of animals there that look more like, they had birth defects and stuff. Like, some mammoths carried horns that were like 10 times bigger than normal. I want to get back into that and recap. So I think I'm going to take a shot at this. 36. Louis Agassiz, a young Swiss naturalist. I think it's on this one. And it's not that long. It's only 36 minutes. So I will get this going here. And, alright. I'm glad you could join me. Thank you. This is Earth on Upheaval, chapters 4 and 5. Good stuff here. Went with Professor Jean Charpentier, another naturalist, to an alpine glacier to demonstrate to him the fallacy of the new idea that an ice sheet once covered a large part of Europe. 4 years before, a teacher in a small town forestry school, A. Bernardi, had written, "Once the polar ice reached as far as the southern limit of the district, which is still marked by erratics." A botanist
had come upon the same idea, probably independently, and coined the term diizite. He had succeeded in winning Charpentier to the hypothesis. At the edge of the glacier, Agassiz, who came as a skeptic, was himself converted. He became the chief apostle of the new theory. He built a hut on the glacier of R and lived in it so that he could observe the movements of the ice, and thereby attracted the attention of naturalists and curiosity seekers all over Europe. The study of the glaciers in the Alps revealed that the glacial ice may move by its own weight a few feet daily. It actually transports stones by carrying and pushing them. Okay, so it does do that too. Some are pushed by advancing the front of the ice to form terminal moraines. When the glacier melts and retreats, the loose rocks remain where they were at the time of the greatest expansion of the glacier. Agassiz assumed that the erratic boulders in the Jura Mountains had been carried there by ice from the Alps, and that the trains of boulders in northern Europe and America had been formed by gigantic glaciers that in the past covered large parts of these continents. He also concluded that the drift had been brought and left by the ice sheet. Ice scratched the underlying rock with the help of flint and other fragments of hard stone. It retained in its grasp, and it polished the rocky floors and slopes and valleys and excavated the beds of lakes. Agassiz made his conclusions with respect to the other parts of the world on the basis of observations limited to Switzerland and its surroundings. He thought that if he could convert two of the leading geologists, Buckland, the author of Reliques de Louvain, and Murchison, to the Ice Age theory, and thus win their support, the task of gaining recognition for it would become much easier. Agassiz went to the British Isles. In later years, as his widow described it, recalling the scientific isolation in which he stood, opposed as he was to all the prominent geologists of the day. He said, "Among the older naturalists, only one stood by me, Dr. Buckland, Dean of Westminster. We went first to the Highlands of Scotland, and it is one of the delightful recollections of my life that as we approached the castle of the Duke of Argyll, standing in a valley not unlike some of the Swiss valleys, I said to Buckland, 'Here we shall find our first traces of glaciers.' And as the stage entered the valley, we actually drove over the ancient terminal moraine, which spanned the opening of the valley. It was a setting for a revelation. Agassiz won a follower." A few weeks later, on November 4th, 1840, Agassiz read a paper before the Geological Society of London, summarizing the excursion in light of the Ice Age theory and Buckland, who was then president of the society, followed by a paper of his own on the same subject. Even before meeting, he had written to Agassiz of the success of his missionary work. "Lyell has adapted your theory in total!" On my showing him a beautiful cluster of moraines within 2 miles of his father's house, he instantly accepted it as solving a host of difficulties that have all his life embarrassed him. Lyell, too, agreed to read a paper less than 3 weeks after this episode, on the day following the Agassiz and Buckland lectures. In this paper, hastily prepared, he explained the moraines in Great Britain in the light of Agassiz's teachings. At the November 4 meeting of the Society, Murchison attempted an opposition, but in the words of Agassiz, did not produce much effect. He added, "Dr. Buckland was truly eloquent." That same year, 1840, Agassiz published his theory in a work entitled Etudes sur les glaciers. He wrote, I'm sorry if I butchered that, "The surface of Europe, previously adorned with tropical vegetation and populated by herds of huge elephants, enormous hippopotami, and gigantic carnivora, was suddenly buried under a vast mantle of ice, covering plains, lakes, seas, and plateaus. Upon the life and movement of a vigorous creation fell the silence of death. Springs vanished, rivers ceased flowing. The rays of the sun rising up this frozen shore, if indeed they reached it, encountered only the breath of winter from the north and the thunder of the crevices as they opened up across the surface of this icy sea. Agassiz regarded the inception and the termination of the Ice Age as catastrophic events. He believed that mammoths in Siberia were suddenly caught in the ice that spread swiftly over the larger part of the globe. He expressed the belief that repeated global catastrophes were accompanied by a fall in the temperature of the globe and its atmosphere, and that glacial ages, of which the Earth experienced more than one, were terminated each time by renewed igneous activity in the interior of the Earth. Eruptions de interieur. Thus, he maintained that the Western Alps had risen up recently, at the end of the last ice age, and were younger than the carcasses of mammoths in Siberia, the flesh of which is still edible. These animals, he thought, had been killed at the beginning of the Ice Age. With the renewal of igneous activity, the ice cover melted. Great floods ensued, and the mountains and lakes in Switzerland and in many other places were formed, and the relief map of the world was generally changed. Come on, man. It is often said that Agassiz added from 500,000 to 1,000,000 years to the recent history of the world by inserting the Great Ice Age between the territory or the age of mammals, and the recent comprising the late Stone Age and historical times. It should be borne in mind, however, that the 1,000,000-year span for the Ice Age is Lyell's estimate, and he interpreted Agassiz's theory in the spirit of uniformity. The theory of a continental ice cover was acceptable to Lyell. He agreed to it, satisfied to go no farther, for his proof then 2 miles from his home. He realized that the floating icebergs could not explain the phenomenon of drift and erratic boulders in all places. The only alternative had been the waves of translation, or tidal waves, traveling on land, but this was outright catastrophic. Now, with the continental ice age theory, he felt he had the correct solution if the catastrophic aspect of the theory, as originally suggested by Agassiz, a follower of Cuvier, was eliminated. It was not yet asked what produced such a cover. End of subchapter.
If I'm not mistaken, in the mid-1990s,
On the Russian plains, soon after the historic meeting at which the Ice Age theory was accepted by the majority of the members of the Geological Society, R.I. Murchison went to Russia, where he had been invited by Tsar Nicholas I to make a geological survey of the empire. Out of this survey grew recognition of the Permian system, the Permian-Silurian, and the Devonian. Also, first recognized by Murchison, Devonian in collaboration with Sedgwick, constitute 3 of the great divisions in the modern concept of early geological ages. For many months, Murchison crossed the latitudes and longitudes of Russia, carefully observing the erratic boulders strewn over the great Russian plains, and rechecking the validity of Agassiz theory. In Finland and northern Russia provinces, he found very large blocks, but they diminished in size the further south one went, which pointed to the action of water, a tide that came down from the north or northeast, spreading rock fragments along its way. He also observed that erratic boulders in the Carpathian Mountains were not of local but of Scandinavian origin. Of the drift, or the piles of stone, sand, clay, and gravel, which are spread out in such enormous masses over the low countries of Russia, Poland, and Germany, Murchison expressed the conviction that a vast portion, by far the greater part, has been transported by aqueous action, consequent of powerful waves of translation of currents occasioned by relative and often paroxysmal changes of the level of sea and land. Paroxysmal changes, that means sudden, violent, in case you wondered, of the level of sea and land, whatever may have been the cause of the eruption of the sea. Such aqueous debacles, with the help of ice flows, produce the drift. Seeing that there are no mountains whatever from which a glacier can ever have been propelled in southern Sweden, Finland, or northeastern Russia, and yet that these regions are powerfully abraded, scored, and polished, Murchison came to the conclusion that effects so extensively developed over such flat countries must have resulted from an erupting sea that also left behind enormous masses of debris and rolled stone. Murchison rejected the application of the terrestrial glacier theory of Sweden, Finland, northeastern Russia, and the whole of northern Germany. In short, to all the Low Countries of Europe. He agreed that in mountainous northern Scandinavia and Lapland, Arctic glaciers formerly did exist. Ice flows, descending from these glaciers, carried angular broken stones over land covered by sea and dropped them on top of the drift created by the eruption of the sea. Murchison called attention to the fact that Siberia is entirely free from erratic blocks, though environed on three sides by high mountains. He required the aid of icebergs detached from the glaciers to account for certain superficial phenomena, but he confidentially maintained that aqueous detrital conditions will best account for the great diffusion of drift over the surface of the globe, and at the same time explain the very general striation and abrasions of the rocks, at low as well as high levels in numerous parallels of latitude. In his later years, Murchison, without retracting any of his observations and conclusions made in Russia, and admitted in a letter to Agassiz that he regretted his early opposition to the Ice Age theory. On the other hand, marine deposits of recent age were found in large areas of European and Asiatic Russia. Caspian Sea, which stretches between southern Russia and Persia, live seals related to the seals of the Arctic Ocean. It is concluded that the polar sea spread and established a connection with the Caspian Sea, and this in recent time. Since ice withdrew, the Arctic Ocean has spread over large areas of northern Russia, and in many places has left marine deposits on the glacial drift as well as on the firmer rocks. The Arctic waters spread also over the Obi Basin far to the south, and established connections with the Caspian Sea, at which time the progenitors of the present seals of the Caspian Rocky Islands migrated thither to become stranded when the waters withdrew. Ice Age in the Tropics. In 1865, Agassiz went to the equatorial Brazil, one of the hottest places in the world, where he found all the signs he ascribed to the action of ice. Now, even those who had previously agreed with him became distressed. An ice cover in the tropics. On the very equator, there were drift accumulations, and scratched rocks, and erratic boulders, and fluted valleys, and the smooth surface of tillite, rock formed of consolidated till. So there must have been ice to carry and polish, and the region must have gone through an ice period. What could have caused a tropical region to be covered by ice several thousand feet thick? Abundant vestiges of an ice age were likewise found in British Guiana, another of the hottest places on Earth. Soon the same word came from equatorial Africa, and what appeared even more strange, the marks there indicated not only that equatorial Africa and Madagascar had been under a sheet of ice, but that the ice had moved, spreading from the equator toward the higher latitudes of the southern hemisphere, or in the wrong direction. The vestiges of an ice age were discovered in India, and there, too, the ice had moved from the equator, and not merely toward higher latitudes, but uphill, from the lowland up the foothills of the Himalayas. On reconsideration, the vestiges of ice in equatorial regions were ascribed to a different ice age that had taken place not thousands, but many millions of years ago. Today, the glacial phenomena in the tropics and in the southern hemisphere are ascribed in the main to the Permian Age, a much earlier period than the recent Ice Age. The most remarkable feature of the Permian glaciation in its distribution, writes C.O. Dunbar of Yale University, South America bears evidence of glaciation in Argentina and southeastern Brazil, even within 10 degrees of the equator. In the northern hemisphere, Peninsular in India within 20 degrees of the equator was the chief scene of the glaciation, with the ice flowing north or from the tropics to higher latitudes. The ice cap covered practically all of southern Africa up to at least latitude 22 degrees south, and also spread to Madagascar. Even if the phenomena took place very long ago, an ice covered thousands of feet thick in the hottest places of the world is a challenging enigma. R.T. Chamberlain says some of these huge ice sheets advanced even into the tropics, where their deposits of glacier-borne debris, hundreds of feet in thickness, amaze the geologists who see them. No satisfactory explanation has yet been offered for the extent and location of those extraordinary glaciers. Glaciers almost unbelievable because of their location and size certainly did not form in deserts. End of subchapter. Greenland. Greenland is a contemporary example of what, according to the Ice Age theory, happened to a large part of the world in times past. Greenland belongs to the great archipelago that crowns northeastern Canada, though it is sometimes regarded as a part of Europe. It is the largest island in the world, if we consider Antarctica and Australia as continents. The island is 1,660 miles long as a part of Europe. It is the largest island in the world, if we consider Antarctica and Australia as continents. The island is 1,660 miles long, largely within the Arctic Circle, reaching the northern latitude of 83 degrees 39. Of its 840,000 square miles of surface, over 700,000 are covered with an immense mountain of ice that leaves free only the coastal fringes. The thickness of the ice is measured by listening to the echo that comes back from the bedrock when a detonation is set off on top of the ice. It is found to be over 6,000 feet thick. For a long time, it was the belief of many that a large region of the interior of Greenland was free from ice and was perhaps inhabited. It was in part to solve this problem that Baron N.A.E. Nordenskjöld set out upon his expedition of 1883. He ascended the ice cap from Disco Bay, latitude 69 degrees, and went eastward for 18 days across the ice field. Rivers were flowing in channels upon the surface like those cut on land, only that the pure blue of the ice walls was, by comparison, infinitely more beautiful. These rivers were not, however, perfectly continuous. After flowing for a distance in channels on the surface, they, one and all, plunged with a deafening roar into some yawning crevasse to find their way to the sea through subglacial channels. Numerous lakes with shores of ice were also encountered. On bending down the ear to the ice, wrote the explorer, we could hear on every side a peculiar subterranean hum, proceeding from rivers flowing within the ice, and occasionally a loud single report like that of a cannon gave notice
of the formation of a new glacier cleft. In the afternoon, we saw at some distance from us a well-defined pillar of mist, which, when we approached it, appeared to rise from a bottomless abyss, into which a mighty glacier river fell. The vast roaring water mass had bored for itself a vertical hole, probably down to the rock, certainly more than 2,000 feet beneath on which the glacier rested. The Ice Age survived in Greenland. This Arctic island reveals how vast continental areas looked in the past. However, it does not explain how ice could have covered British Guiana or Madagascar in the tropics. And what is no less surprising, the northern part of Greenland, according to the concerted opinion of glaciologists, was never glaciated. Probably then, as now, an exception was the northernmost part of Greenland, for it seems a rule that the most northerly lands were not, and never were, glaciated, writes the polar explorer Vilhelmur Stefansson. The islands of the Arctic archipelago, writes another scientist, were never glaciated. Neither was the interior of Alaska. It is a remarkable fact that no ice mass covered the lowlands of northern Siberia, any more than those of Alaska, wrote James D. Dana, the leading American geologist of the last century. In northern Siberia, on the polar islands in the Arctic Ocean, spires of rock were observed that would certainly have been broken off if an ice cover had moved over these parts. Bones of Greenland reindeer have been found in southern New Jersey and southern France, and bones of Lapland reindeer in the Crimea. This was explained as due to the invasion of ice and the retreat of northern animals to the south. The hippopotamus was found in France and England, and the lion in Alaska. To explain similar occurrences, an interglacial period was introduced into the scheme. The land was warmed up, and the southern animals visited northern latitudes, and since the change from one fauna to another took place repeatedly, 4 glacial periods with 3 interglacial were generally counted, though the number of periods is not consistent with all lands or with all investigators. But why the polar lands were not glaciated during the Ice Age has never been explained. Greenland presents still another enigma in the preceding formations, those of the Territory Age. In the 1860s, O'Hear or Zurich published his classical work on the fossil plants of the Arctic. He identified the plant remains of northern parts of Greenland as magnolia and fig trees, among other species. Forests of exotic trees and groves of juicy subtropical plants grew in the land that lies deep in the cold Arctic and is immersed yearly in a continuous polar night of 6 months' duration. Corals of the polar regions. Spitsbergen in the Arctic Ocean is as far north from Oslo in Norway as Oslo is from Naples. Hare identified 136 species of fossil plants from Spitsbergen, 78 degrees 56 north latitude, which he ascribed to the Territory Age. Among the plants were pines, firs, spruces, cypresses, also elms, hazels, and water lilies. At the northernmost tip of Spitsbergen archipelago, a bed of black and lustrous coal 25 to 30 feet thick was found. It is covered with black shale and sandstone encrusted with fossilized land plants. When we remember that this vegetation grew luxuriantly within 8 degrees 15 of the North Pole, a region which is in darkness for half of the year and is now almost continuously buried under snow and ice, we can realize the difficulty of the problem and the distribution of climate which these facts present to the geologist. There must have been great forests on Spitsbergen to produce a bed of coal 30 feet thick. And even if Spitsbergen, almost 1,000 miles inside the Arctic Circle, for some unknown reason, had the warm climate of the French Riviera on the Mediterranean,
Still, these thick forests could not have grown there, because the place is 6 months in continuous night. The rest of the year, the sun stands low over the horizon. Not only fossil trees and coal, but corals, too, were found there. Corals grew only in tropical water. In the Mediterranean, in the climate of Egypt or Morocco, it is too cold for them. But they grew in Spitsbergen. Today, large formations of coral covered with snow can be seen. It does not solve the problem of their deposition if they were formed in an older geological epoch. At some time in the remote past, corals grew and are still found on the entire fringe of polar North America, in Alaska, Canada, and Greenland. In later times, territory fig palms bloomed within the Arctic Circle. Forests of Sequoia gigantea, the giant tree of California, grew from Bering Strait to north of Labrador. It is difficult to imagine any possible conditions of climate in which these plants could grow so near the pole, deprived of sunlight for only months of the year. Not unless it's going around a brown dwarf or a red one. It is usually said that in ages past, the climate all over the world was the same, or that a characteristic of the warm periods, which have formed the major part of geological time, was the small temperature difference between equatorial and polar regions. To this, C.E.P. Brooks, in his book Climate Through the Ages, says, "So long as the axis of rotation remains in nearly its present position relative to the plane of the Earth's orbit around the Sun, the outer limit of the atmosphere in tropical regions must receive more of the Sun's heat than in the middle latitudes, and in the middle latitudes more than in the polar regions. This is an invariable law. It is much more difficult to think of a cause which will raise the temperature of polar regions by some 30 degrees Fahrenheit or more, while leaving that of the equatorial regions almost unchanged. The continent of Antarctica is larger than Europe, European Russia included. It has not a single tree, not a single bush, not a single blade of grass. Very few fungi have been found. Reports of polar explorers indicate that no land animals larger than insects have been seen, and these insects are exceedingly few and degenerate. Penguins and seagulls come from the sea. Storms of great velocity circle the Antarctic most of the year. The greatest part of the continent is covered with ice that in some places descends into the ocean. E.H. Shackleton, during his expedition to Antarctica in 1907 to 1909, found fossil wood in the sandstone of a moraine at latitude 85 degrees 5, and he also found erratic boulders of granite on the slopes of Mount Erebus, a volcano. Then he discovered 7 seams of coal, also at about latitude 85 degrees. The seams are each between 3 and 7 feet thick. Associated with the coal is sandstone containing coniferous wood. Antarctica, too, must have had great forests in the past. It often appears that the historian of climate has chosen a field as hard to master as it is to square the circle. It seems sometimes that the history of climate is a collection of unsolved, even unsolvable questions, without drastic changes in the position of the terrestrial axis, or in the form of the orbit, or both. Conditions could not have existed in which tropical plants flourished in polar regions. If anyone is not convinced of this, he should try to cultivate coral at the North Pole. Whales in the mountains. In bogs covering glacial deposits in Michigan, skeletons of 2 whales were discovered. Really? Whales are marine animals. How did they come to Michigan in the post-glacial epoch? Whales do not travel by land. Glaciers do not carry whales, and the ice sheet would not have brought them to the middle of a continent.
Besides, the whale bones were found in post-glacial deposits. Was there a sea in Michigan after the glacial epoch only a few thousand years ago? In order to account for whales in Michigan, it was conjectured that in post-glacial epoch, the Great Lakes were part of an arm of the sea. At present, the surface of Lake Michigan is 582 feet above sea level. Bones of whale have been found 440 feet above sea level, north of Lake Ontario. The skeleton of another whale was discovered in Vermont, about 500 feet above sea level, and still another in the Montreal, Quebec area, about 600 feet above sea level. Although the Humphrey whale and beluga occasionally enter the mouth of the St. Lawrence Seaway, they do not climb hills. To account for the presence of whales in the hills of Vermont and Montreal at elevations of 500 and 600 feet requires the lowering of the land to that extent. Another solution would be for an ocean tide carrying the whales to have trespassed upon the land. In either case, Herculean force would have been required to push mountains below sea level or to cause the sea to erupt. But the later explanation is clearly catastrophic. Therefore, the accepted theory is that the land in the region of Montreal and Vermont was depressed more than 600 feet by the weight of ice and kept in this position for a while after the ice melted. But along the coast of Nova Scotia and New England, stumps of trees stand in water, telling of once forested country that became submerged. And opposite the mouths of the St. Lawrence and the Hudson rivers are deep canyons stretching for hundreds of miles into the ocean. These indicate that the land became sea, being depressed in post-glacial times. Then did both processes go on simultaneously in neighboring areas? Here up, there down, a species of territory whale, Zelugodon, left its bones in great numbers in Alabama and other Gulf states. The bones of these creatures covered the fields in such abundance and were so much of a nuisance on the top of the ground that the farmers piled them up to make fences. There was no ice cover in the Gulf states. Then what had caused the submergence and emergence of the land there? The ocean coast, not only of the area covered by ice, but all the way from Maine to Florida, was at one time submerged and then uplifted. Reginald A. Daly of Harvard wrote, "Not long ago, in a geological sense, the flat plain from New Jersey to Florida was under sea. At that time, the ocean surf broke directly on the old Appalachian Mountains. The wedge-like mass of marine sediments was then uplifted and cut into by rivers, giving the Atlantic coastal plain of the United States. Why was it uplifted? To the westward are the Appalachians. The geologist tells us of the stressful times when a belt of rocks extending from Alabama to Newfoundland was jammed, crumpled, and thrust together to make this mountain system. Why? How was it done? In former times, the sea flooded the region of the Great Plains, from Mexico to Alaska, and then withdrew. Why this change? In Georgia, marine deposits occur at altitudes of 160 feet, and in northern Florida at altitudes of at least 240 feet. Walrus is found in Georgian deposits. Pleistocene, Ice Age, marine features are present along the Gulf Coast, east of the Mississippi River. In some places, at altitudes that may exceed 200 feet. In Texas, mammalian land animals of the Ice Age were found in marine deposits. These areas were not covered by the ice, which, advancing from the north, reached only as far as Pennsylvania. A marine deposit overlays the seaboard of the northeastern states and the Arctic coast of Canada. In this deposit, walrus, seals, and at least 5 genera of whales are found. Marine deposits of land identified with both glacial and interglacial ages, or containing animals of Arctic and of temperate latitudes.
exist along both Arctic and Pacific coasts in places extending more than 200 miles inland.
Of course, leave it up to me to pick
The change in land elevation in the region previously
pretty
covered
good.
by ice is ascribed to the removal of the ice cover that weighed down the Earth's crust. But what changed the elevation of the other areas outside of the ice cover? If the land slowly rose when freed from the ice and carried the bones of whales to the summits of hills, why did the neighboring land subside miles deep, as the undersea canyons indicate? Daly concluded the Pleistocene history of North America holds 10 major mysteries for every one that has already been solved. End of chapter. Happened to a large part of the world in times past. Greenland
years, like all of us hadn't for years.
Yeah.
Go, Greg.
Oh, there's Greg.
Yeah, we're on.
Oh,
There you go.
hey,
What? What? I never heard of that. I would love to hear. Oh, I've never heard of that. Oh man, I love that stuff. I love that kind of stuff. Oh, okay. Now,
right, Greg, that Discord isn't working. I can speak all right on Skype.
Greg, well, you should see the setup we've got. You should see the setup we've got. So Paulie and I are on Discord, and Nick's on Skype, so you can hear him via my speakers.
yeah. Oh, I do want to hear this. Get it back. There, that's a good idea.
So let's go for it.
They are. Nick will be back in 30 minutes. So there you go.
You want to hear? I want to hear.
You still there, Greg? Yep. All I'll say,
1895 and
when you get a chance, Nick,
the time
and
was
probably
right
get
for
to
Harris.
Skype going, you'll have to
180
send it
years
to.
ago, in 1773, Pierre Simon de Laplace, 1749 to 1827. Then 23 years old, stood before the Académie des Sciences in Paris and read a paper in which he proved the stability of the solar system. All deflections of the planets from their paths are only periodic oscillations from their mean courses, and the celestial mechanism is wound up to go on forever. Laplace's contemporary, Jean-Baptiste de Lamarck, 1744 to 1829, set out to demonstrate in a series of works that this Earth has ever been a peaceful abode of evolution, free from spasmodic disturbances, in opposition to the dominant ways of his day. These ideas of harmony or stability in the celestial and terrestrial spheres gained ground in the 19th century and became the foundation of scientific thought. In 1846, Leverrier, by announcing the existence of the planet Neptune, which was immediately thereafter discovered in the part of the sky indicated by him, proved the gravitational theory of Newton and the orderly universe of Laplace to be correct. However, in the same year, by detecting the anomaly in the revolution of Mercury, always accumulating in one and the same direction, he threw the first doubt on the infallibility of these very laws. The theory of uniformity, as understood by Lamarck and Hutton, was developed by Lyell, became the cornerstone of Darwinian theory, and Darwin went so far as to say that anybody who was unconvinced by Lyell's teaching should refrain from reading The Origin of Species. The principle of uniformity, or the explanation of all past events in the history of the globe, and in terms of the processes in action in our own age, or the denial of catastrophic crisis in the past, gave Darwin what he needed most for his idea of the origin of species: almost unlimited time, in order that from the struggle for existence or competition new forms should evolve, and that an animal like the spider with its many legs and human beings should have had a common ancestor. Untold eons were necessary. By the end of the 19th century, the war between the theory of evolution and the theory of creation in 6 days, less than 6,000 years ago, was concluded with victory to the theory of evolution. The difficulty left was, in the view of Thomas Huxley, that no really new species had appeared on the world scene since the scientific observations were made. Not even the breeding experiments. The breeding experiments, just what would that be about?
Very interesting.
The geological record, however, spoke unequivocally of the fact, in the past, lived animal forms that do not live any longer. And of those forms that live in our age, many were not present in the geological past. Laplace's theory of the origin of the solar system, of a rotating nebula, was replaced by the end of the century with a theory of a catastrophic beginning in a near collision of the Sun with another star, with debris forming the planets. Isn't that interesting? And what star was that other star? And where did that information come from? But it was stressed by the authors of this new theory that the universe is orderly, and this beginning in a cataclysm was an unusually rare occurrence in the cosmos, and that the solar system is governed by the principle of stability, as enunciated by Laplace, and the Earth by a law of uniformity, in the animals and plants by the law of evolution through continuity. It appeared that basic principles, having been established,
Science had before it only the work of refinement and observation, and in the addition of details for perfection of knowledge. But the time of basic discoveries was over. This was the outlook in 1895. In April of that year,
Fridtjof Nansen,
in an attempt to discover the North Pole, reached a point less than 4 degrees from it. The scientific world looked upon the discovery of the North Pole as the most coveted goal still left to be attained by science. But before Nansen, drifting from latitude 8614, reached his home in Norway, the scene changed. Conrad Röntgen of Würzburg discovered the X-rays, or cathode rays, that pass through opaque bodies. In the same year of 1895, 20-year-old Marconi, working at the home of his father near Bologna, made the first successful experiment with wireless transmission. Okay, now I have read that he ripped off Tesla when he was his understudy, and that Bologna was notorious for having self-important
tricksters and evildoers.
intellectuals there that were made fun of by a comedy troupe, and that's where the saying, "you're full of baloney," came from. That year, too, Sigmund Freud published his first paper, together with Joseph Breuer, which led to a new understanding of the realm known as the subconscious. And at the same time, Pavlov made his contribution to the psychology of the reflexes. Pavlov's dog. The next year, and still before Nansen had landed on the Norwegian coast, Henry Becquerel, working on uranium, discovered the phenomena of radioactivity. 2 years later, he was followed by the Curies, who discovered radium. In 1897, J.J. Thomson announced that the atom is divisible and is actually a microcosm. And he was followed by Rutherford. In 1900, Planck presented the theory of quanta, or inner.
Welcome, Manuel Velikovsky's Earth and Upheaval. Very good information here. You're going to like. Let's get into it. Chapter 6. Mountain Thrusts in the Alps and elsewhere. The age of a rock formation is ascertained with the help of fossils it contains. To the surprise of many scientists, it was found that the mountains had traveled since older formations have been pushed over on top of younger ones. Chief Mountain in Montana is a massive standing several thousand feet above the Great Plains. It has been thrust bodily upon the much younger strata of the Great Plains, and then driven over them eastward for a distance of at least 8 miles. Indeed, the thrust may have been several times 8 miles, writes Daly. By similar thrusting, the whole Rocky Mountain front for hundreds of miles has been pushed up and then out many miles over the plains. Such titanic displacements of mountains have been found in many places on the earth. The displacement of the Alps is especially extensive. During the building of the Alps, gigantic slabs of rock, thousands of feet thick, hundreds of miles long, and tens of miles wide, were thrust up and then over, relatively to the rocks beneath. The direction of the relative overthrusting movement was from Africa toward the main mass of Europe on the north. The visible rocks of the northern Alps of Switzerland have thus been shoved northward distances of the order of 100 miles. In a sense, the Alps used to be on the present site of northern Italy. Mount Blanc was moved from its place and the Matterhorn was overturned. These portions of the Alps that surround the valley of the Linth and the canton of Glarus in Switzerland have lower parts of the tertiary formations or of the age of mammals. Their upper parts are Permian, preceding the age of reptiles, and Jurassic, the age of reptiles. This impels
to one of two conclusions. Either the division of rocks into sequences based on fossils they contain is fallacious, or the old mountains were moved bodily and set on the shoulders of more recent formations. The latter conclusion is chosen. And if de Sauzier's notion of the sea sweeping over the Alps appeared fantastic, the idea of mountains traveling considerable distances must sound even more fantastic, unless we know of a physical cause that could have brought it about, but even the very cause of mountain building itself is obscure. The problem of mountain making is a vexing one. Many of them, mountains, are composed of tangentially compressed and overthrust rocks that indicate scores of miles of circumferential shortening in the Earth's crust. Radial shrinkage is woefully inadequate to cause the observed amount of horizontal compression. Therein lies the real perplexity of the problem of mountain making. Geologists have not yet found a satisfactory escape from this dilemma, says F.K. Mather of Harvard University. The origin of the mountains is not explained, and still less is their thrust or shift across valleys and over other mountains. The Alps were shoved 100 miles to the north. Chief Mountain in Montana traveled across the plains and climbed the slope of another mountain and settled on top of it. All of the Glacier National Park in Montana and all of the Rocky Mountain area up to Yellowhead Pass in Alberta moved for many miles. The mountains of westward Scotland shifted from their places. The entire length of the Norwegian mountains showed a similar overthrust. What could have caused these mountains to travel across valley and uphill with their masses of granite weighing billions of tons? No force acting from inside the earth, pulling inward or pushing outward, could have created these overthrusts. Only twisting could have produced them. It could hardly have occurred if the rotation and revolution of our planet had never been disturbed. In the Alps, caverns with human artifacts of stone and bone dating from the Pleistocene Ice Age have been found at remarkably high altitudes. During the Ice Age, the slopes and valleys of the Alps, more than other parts of the continent, must have been covered by glaciers. Today in Central Europe, there are great glaciers only in the Alps. The presence of men at high altitudes during the Pleistocene or Paleolithic rude stone age seems baffling. The cavern of Wildkirchili near the top of Ebenalp is 4,900 feet above sea level. It was occupied by man sometime during the Pleistocene. Even more remarkable in respect to altitude is the cavern of Drachenlach, advance of ice, and this in the eyes of D. Terra, working for the Carnegie Institution, with the assistance of Professor T.T. Patterson of Harvard University, is one long argument. Ice certainly did not form in deserts. End of subchapter. Greenland. Greenland related to the seals of the Arctic Ocean. It is concluded that the polar sea spread and established a connection with the Caspian Sea, and this in recent time. Beautiful cluster of moraines within 2 miles of his father's house. He instantly accepted it as solving a host of difficulties at low as well as high level, perfectly continuous. After flowing for a distance in channels on the surface, they, one and all, plunged with a deafening roar into some yawning crevasse, to find their way to the sea through subglacial channels.
Numerous lakes with shores of ice were also encountered. On bending down the ear to the ice, wrote the explorer, we could hear on every side a peculiar subterranean hum of northern Siberia, any more than those of Alaska, wrote James D. Dana, the leading American geologist. Its present position relative to the plane of the In later times, territory fig palms bloomed within the Arctic Circle. Forests of sequoia. Was there a sea in Michigan after the glacial epoch? Only a later explanation is clearly catastrophic. Therefore, the accepted theory is that the land in the region of Montreal and Vermont was depressed more than 600 feet by the weight of ice and kept in this position for a while after the ice melted. But along the coast of Nova Scotia and New England, stumps of trees stand in water, telling of once forested country that became submerged. And opposite the mouths of the St. Lawrence and the Hudson rivers are deep canyons stretching for hundreds of miles into the ocean. These indicate that the land became sea, being may seem to a modern geologist. Studies on the Ice Age in India and associated human cultures, published in 1939 by D. Terra, working for the Carnegie Institution, with the skeletons of marine animals. By their extreme youth, wrote the have occurred within the Pleistocene epoch, Ice Age itself. It was occupied by man sometime during the Pleistocene. Even more remarkable, that indicate scores of miles of circumferential shortening in the Earth's crust. Radial shrinkage is woefully inadequate to cause the observed amount of horizontal compression. Therein lies the real perplexity of the problem of mountain making. Geologists have not yet found a satisfactory escape from this dilemma, says F.K. Mather of Harvard University. The origin of the mountains is not explained, and still less is their thrust or shift across valleys and over other mountains. The Alps were shoved 100 miles to the north. Chief Mountain in Montana traveled across the plains and climbed the slope of another mountain and settled on top of it. All of the Glacier National Park in Montana and all of the Rocky Mountain area up to Yellowhead Pass in Alberta moved for many miles. The mountains of westward Scotland shifted from their places. The entire length of the Norwegian mountains showed a similar overthrust. What could have caused these mountains to travel across valley and uphill with their masses of granite weighing billions of tons? No force acting from inside the earth, pulling inward or pushing outward, could have created these overthrusts. Only twisting could have produced them. It could hardly have occurred if the rotation and revolution of our planet had never been disturbed. In the Alps, caverns with human artifacts of stone and bone dating from the Pleistocene Ice Age have been found at remarkably high altitudes. During the Ice Age, the slopes and valleys of the Alps, more than other parts of the continent, must have been covered by glaciers. Today in Central Europe, there are great glaciers only in the Alps. The presence of men at high altitudes during the Pleistocene or Paleolithic rude stone age seems baffling. The cavern of Wildkirchili near the top of Ebenalp is 4,900 feet above sea level. It was occupied by man sometime during the Pleistocene. Even more remarkable in respect to altitude is the cavern of Drachenloch at height of 2445 meters, 8,028 feet, near the top of Drechenberg, south of Ragaz. This is a steep, snow-covered massif. Both of these stations are in the very heart of the alpine field of glaciation. The continental ice sheet, thousands of feet thick, filled the entire valley between the Alps and the Jura,
where now Lake Geneva lies, to the height of the erratic boulders torn from the Alps and placed on the Jura Mountains, in the same geological epoch between two advances of the ice cover during an interglacial intermission. Human beings must have occupied caverns 8,000 feet above sea level. No satisfactory explanation for such location of Stone Age man has ever been offered. Could it be that the mountains rose as late as in the age of man and carried up with them the caverns of early man? In recent years, evidence has grown rapidly to show, in contrast to previous opinions, that the Alps and other mountains rose and attained their present heights, and also traveled long distances in the age of man. Mountain uplifts amounting to many thousands of feet have occurred within the Pleistocene epoch, Ice Age, itself. This occurred with the Cordilleran mountain system in both North and South America, the Alps, Caucasus, Central Asian system, and many others. The fact of the late upthrust of the major ridges of the world created, when recognized, great perplexity among geologists who, under the weight of much evidence, were forced to this view. The revision of the concepts is not always radical enough. Not only in the age of man, but in the age of historical man. Mountains were thrust up, valleys were torn out, lakes were dragged uphill and emptied. Helmut Gams and Rolf Nordhagen brought together very extensive material concerning the Bavarian Alps and the Tyrol, or Eastern Alps. We shall deal with this material in Chapter 11, Climasters. The great mountain chains challenged credulity by their extreme youth, wrote the explorer Bailey Willis in the Asian Mountains. The Himalayas. The Himalayas, highest mountains in the world, rise like a 1,000-mile-long wall north of India. This mountain wall stretches from Kashmir in the west to and beyond Bhutan in the east, with many of its peaks towering over 20,000 feet. Mount Everest reaching 29,000 feet, or over 5 miles. The summits of these lofty massifs are capped by eternal snow in those regions of the heavens where eagles do not fly, nor any other bird of the sky. Scientists of the 19th century were dismayed to find that, as high as they climbed, the rocks of the massifs yielded skeletons of marine animals, fish that swim in the ocean, and shells of mollusks. And marine animals looked down to where now we look up, and where man, after many unsuccessful efforts, has until now succeeded only once in putting his feet. Until recently, it was assumed that the Himalayas rose from the bottom of the sea to their present height tens or perhaps hundreds of millions of years ago. Such a long period of time, so long ago, was enough even for the Himalayas to have risen to their present height. Do we not, when we tell young listeners the story about giants and monsters, begin with once upon a time, long, long ago? And the giants are no longer threatening, and the monsters are no longer real. According to the general geological scheme, 500 million years ago, the first forms of life appeared on the Earth. 200 million years ago, life developed into reptilian forms that dominated the scene, achieving gigantic size. The huge reptiles died out 70 million years ago, and mammals occupied the Earth. They belong to the Tertiary. According to this scheme, the last mountain uplifts took place at the end of the Tertiary, during the Pleistocene. This period lasted until 1 million years ago, when the Quaternary period, the age of man, began. The Quaternary is also the time of the Ice Age, or the Pleistocene. the Paleolithic or Old Stone Age, and the very end of the Quaternary since the end of the Ice Age is called Recent Time. The Neolithic, late or polished stone, bronze and iron cultures. Since the appearance of man on Earth, or since the beginning of the Ice Age, there have been no uplifts on any substantial scale. In other words, we have been told the profile of the Earth with its mountains and oceans was already established when man first appeared. In the last few decades, however, numerous facts have emerged from mountains and valleys that tell a different story. In Kashmir, Helmut de Terra discovered sedimentary deposits of an ancient sea bottom that was elevated at places to an altitude of 5,000 feet or more, and tilted at an angle of as much as 40 degrees. The basin was dragged up by the rise of the mountain. But this was entirely unexpected. These deposits contain Paleolithic fossils, and this, according to Arnold Heim, Swiss geologist, would make it plausible that the mountain passes in the Himalayas may have risen in the age of man, 3,000 feet or more. However fantastic changes so extensively may seem to a modern geologist, studies on the Ice Age in India and associated human cultures, published in 1939 by de Terra, working for the Carnegie Institution, with the assistance of Professor T.T. Patterson of Harvard University, is one long argument and demonstration that the Himalayas were arising during the Glacial Age and reached their present heights only after the end of the Glacial Age. And actually, in historical times, from other mountain ridges came similar reports. De Terra divided the Ice Age of the Kashmir slopes of the Himalayas into Lower Pleistocene, embracing first glacial and interglacial stages, Middle Pleistocene, the second major glaciation, and the following interglacial, and the Upper Pleistocene, comprising the last two glaciations and an interglacial stage. The scenery with this region presented at the beginning of the Pleistocene must have differed greatly from that of our time. The Kashmir Valley was less elevated, and its southern rampart, the Pir Panajel, lacked that alpine grandeur that enchants the traveler today. Then various formation groups moved both horizontally and vertically, resulting in a southward displacement of older rocks upon foreland sediments accompanied by uplift of the mobile belt. The main Himalayas suffered sharp uplift, in consequence of which the Kashmir lake beds were compressed and dragged upward on the slope of the most mobile range. Uplift was accompanied by a southward shifting of the Pir Panajel block toward the foreland of northwestern India. The Pir Panajel massif that was pushed toward India is at present 15,000 feet high. In the beginning of this period, the fauna was greatly impoverished, but thereafter, judging from remains, large cats, elephants, true horses, pigs, and hippopotami accompanied the area. In the Middle Pleistocene, or Ice Age, there was a continued uplift. The archaeological records prove that early Paleolithic man inhabited the adjoining plains. De Terra refers to abundance of Paleolithic sites. Man used stone implements of flake form like those found in the Cromer forest bed in England. Then once more the Himalayas were pushed upwards. Tilting of terraces and lacustrine beds indicates a continued uplift of the entire Himalayan tract during the last phases of the Ice Age. In the last stages of the Ice Age, when man worked stone in the mountains, he might have been living in the Bronze Stage down in the valleys. It has been repeatedly admitted by various authorities, quoted subsequently in this book, that the end of the glacial epoch may have been almost contemporaneous with the time of the rise of the great cultures of antiquity of Egypt and Samaria, and it follows also of India and China. The Stone Age, in some regions, could have been contemporaneous with the Bronze Age in others.
It has to be.
Even now, there are numerous tribes in Africa, Australia, and Tierra del Fuego, the southern tip of the Americas, still living in the Stone Age, and many other regions of the modern world would have remained in the Stone Age had it not been for the importation of iron from more advanced regions. The Aborigines of Tasmania never got so far as to produce a polished Neolithic stone implement, and in fact barely entered the crudest Stone Age. This large island south of Australia was discovered in 1642 by Abel Tasman. The last Tasmanian died in exile in 1876, and the race became extinct. I always thought a Tasmanian was just a name. I didn't know they were humans. The more recent uplifts in the Himalayas took place also in the age of modern man. The post-glacial terrace record suggests that there was at least one prominent post-glacial advance of ice, and this, in the eyes of De Terra and Patterson, is indicative of a diastrophic movement of the mountains. We must be emphatic on one particular feature, namely the dependence of Pleistocene glaciation on the diastrophic character of a mobile mountain belt. This relationship, we feel, has not been sufficiently recognized. On the other glaciated regions, such as Central Asia and the Alps, where similar, if not identical, conditions are found. It had been generally assumed that loess, thin, wind-blown dust that is built into clays, is a product of a glacial age. However, in the Himalayas, De Terra reported finding Neolithic or polished stone implements in loess, and commented, of importance for us is the fact that loess formation was not restricted to the glacial age, but that it continued into post-glacial times. In China and in Europe, too, the presence of polished stone artifacts in loess prompted a similar revision. The Neolithic stage that began according to the accepted scheme at the end of the Ice Age still persisted in Europe and in many other places at the time when, in the centers of civilization, the Bronze Age was already flourishing. R. Feinserwalter, exploring the Nanga Parbat Massif in western Himalayas, 26,660 feet high, dated the Himalayan glaciation as post-glacial. In other words, the expansion of the glaciers in the Himalayas took place much closer to our time than had been previously assumed. Great uplifts of the Himalayas took place, in part, after the time designated as the Ice Age, or only a few thousand years ago. Heim investigated the mountain ranges of western China, adjacent to Tibet, and east to the Himalayas, came to the conclusion, 1930, that they had been elevated since the glacial age. The great massif of the Himalayas rose to its present height in the age of modern, actually historical man. The highest mountains in the world were also the youngest. With their topmost peaks, the mountains have shattered the entire scheme of geology of the long, long ago. End of subchapter. The Siwalik Hills. The Siwalik Hills are in the foothills of the Himalayas, north of Delhi. They extend for several hundred miles and are 2,000 to 3,000 feet high. In the 19th century, their usually rich fossil beds drew the attention of scientists. Animal bones of species and genera, living and extinct, were found there in the most amazing profusion. Some of the animals looked as though nature had conducted an abortive experiment with them and had discarded the species as not fit for life. The carapace of a tortoise 20 feet long was found there. How could such an animal have moved on a hilly terrain? The Elephas ganesa, an elephant species found in the Siwalik Hills, had tusks about 14 feet long and over 3 feet in circumference. One author says of them, "It is a mystery how these animals ever carried them, owing to their enormous size and leverage." The Siwalik fossil beds are stocked with animals of so many and such varied species that the animal world of today seems impoverished by comparison. It looks as though all of these animals invaded the world at one time. This sudden bursting on stage of such a varied population of herbivores, carnivores, rodents, and primates of the highest order of the mammals must be regarded as a most remarkable instance of rapid evolution of species, writes D.N. Wadia in his Geology of India. The hippopotamus, which generally is a climatically specialized type, Deutera, pigs, rhinoceroses, apes, oxen filled the interior of the hills almost to bursting. A.R. Wallace, who shares with Darwin the honor of being the originator of the theory of natural selection, was among the first to draw attention in terms of astonishment to the Siwalik extinction. Many of the genera that comprised a wealth of species were extinguished to the last one. Some are still represented, but only by a few species. Of nearly 30 species of elephants found in the Siwalik beds, only one species has survived in India. The sudden and widespread reduction by extinction of the Siwalik mammals is a most startling event for the geologist as well as the biologist. The great carnivores, the varied races of elephants, belonging to no less than 25 to 30 species, the numerous tribes of large and highly specialized ungulates, hoofed animals, which found such suitable habitats in the Siwalik jungles of the Pleistocene epoch, no more in an immediately succeeding age. It used to be assumed that the advent of the Ice Age killed them, but subsequently it has been recognized that great destructions took place in the age of man, much closer to our day. The older geologists thought that the Siwalik deposits were alluvial in their nature, that they were debris carried down by the torrential Himalayan streams. But it was realized that this explanation does not appear to be tenable on the ground of the remarkable homogeneity that the deposit possess, and a uniformity of lithologic composition in a multitude of isolated basins at considerable distances from one another. There must have been some agent that carried these animals and deposited them at the feet of the Himalayas, after the passage of a geological age repeated the performance. For in the Siwalik Hills, there are animals of more than one age and signs of more than one destruction. There was also a movement of the ground. The disrupted part of the fold has slipped boldly over for long distances, thus thrusting the older pre-Siwalik rock of the inner ranges of the mountains over the younger rocks of the outer ranges. If the cause of these paroxysms and destruction was not local, it must have produced similar effects at the other end of the Himalayas and beyond that range. 1,300 miles from the Silawalik Hills in central Burma, the deposits cut by the Irrawaddy River may reach 10,000 feet. Two fossoriferous horizons occur in this series, separated by about 4,000 feet of sands. The upper horizon bed, characterized by mastodon, hippopotamus, and ox, is similar to one of the beds in the Silawaliks. The sediments are remarkable for the large quantities of fossil wood associated with them. Hundreds and thousands of entire trunks of silicified trees and huge logs laying in the sandstones suggest the denudation of thickly forested areas. Animals met death and extinction by the elementary forces of nature, which also uprooted forests from Kashmir to Indochina, threw sand over species and genera in the mountains, thousands of feet high.
End of subchapter. That was pretty crazy. Never heard of Silawak.
Tiwanaku in the Andes.
I'm like Uncle Joe. I'm moving kind of slow. I'm kind of tired, man. It's been a long night. We went at it pretty good, didn't we?
Yeah.
Where are you guys at in the chat? Yeah, you too. I meant that for you too. Where are you guys at in the chat? You still there? Did you go? You there? Yeah, you're still there. Hello. Boom. Now you can hear me, right? Hello? Hello? Yellow. Calling Grouch and St. Pauli girl. Yellow. Okay, well, you'll come to the phone when you do. I just wanted to, let's see. Yeah, that's kind of crazy about that Silawak Hills. Like, what's all that about?
Yeah.
They have some kind of a crazy, like, doctor, what's his name there?
Yellow.
Yeah.
Yeah.
Don't
What was that guy's name? Doctor something. He was on
Hey, Greg.
He was on that island making all them weird creatures. And then, you got them, you got those creatures in Egypt and other countries where they're like half dog and, centaurs.
Oh,
I wonder if things like that really did exist sometime,
Oh, I think I just heard Polly Girl. I'm here.
uh-huh. I'm here. Hello.
Hey.
Yes. Do you really think that centaurs and...
Well, I don't know. It's just like, they have such a rich freaking mythology, and it's almost like they really existed, like some crazy Doctor Who or whatever was messing around with DNA, I don't know, but we can do it today. So
Nature does a better job of messing around with DNA than anything else.
For sure.
Electrical discharge changes DNA.
Yeah.
It's been proven in the labs. So yeah,
Mm-hmm.
and these massive charges from the thunderbolts of the gods certainly did things to us, changed us in ways that we can't fathom at the moment. Changes in our brain structure, changes to our bodies, the size of our bodies. Gordon Doherty was talking about how the Earth is smaller and in the Saturnian age and drier.
Yeah.
We didn't have oceans. Well, we probably had small oceans, but you know.
Wallet.
You got the wallet.
A coat pocket. Sorry, guys. I should mute. Here, keep talking. I'm sorry. My son was asking. He wants to go to the store. Okay, go ahead.
That motherfucker's
Stop. Oh. Aye. Hold on.
them niggas, man.
All right. Bam.
Oh, that's great. Thought he turned his mic off.
Talking about electric, electric, whatever, like huge plasma events, electrical charges could change DNA and cause all kinds of things.
Well, yeah. I mean, it's the creative force. So
That reminds me of this movie I just watched. It's called Bright,
Yeah.
and it's with this guy that's in it. Anyway, and it's it's like modern nowadays time, but I mean there's orcs and there's fairies and there's there's all the different kinds of mythical things like there's centaurs and stuff, and they're walking around and they for some reason this movie pulls it off where it just integrates. It's like, what if all that stuff actually did exist and it still exists and we still live with it? And it's,
I know.
I mean, it's that movie. It was really cool to watch all that because it was just cool.
Yeah.
I mean, I don't know. It's kind of a weird idea to come up with if you think about it. Making putting a guy's torso on a horse's body.
Yeah. Well, not that puts a lot of gravity into the situation, but Richard Hoagland is convinced that Star Wars is our true past. Have you ever listened to him talk about it?
Yes.
Yeah.
Whatever happened to him? I don't hear about from him at all ever.
He's probably just retired, I don't know. I haven't seen him in a while, and he's got that.
People have great ideas, and then people have shit ideas. I mean, I've said it before, and I'll say it again. People have pieces to the puzzle, but other things that they talk about are just like whack, like crazy, like not true, and they think that because they've figured out one piece of the puzzle that they've got all the rest of it figured out, and no. It's a little bit more complex than we think it is.
Yeah.
Occam's razor unfortunately doesn't apply when we're talking about the universe, and so some historical events. Occam's razor doesn't apply.
When you were reading and you were reading how the mountains weren't they were twisted, like
I
and I was trying to picture in my mind what that would actually be like to actually see that would just
the earth was twisted.
I mean, incredible power.
Absolutely.
Well, if the globe did flip, that would have caused the surface to bunch up in places and rip open in other places, and that's exactly what's described in these cataclysms that we've seen. Mountains would have been moved, but with the storms, that and they would have been built by these supersonic winds, updrafts and downdrafts that Andrew Hall describes.
Right.
A lot of material is etched out of the ground in one area, picked up along with the bones and the meat of just recently killed animals and trees, and picked up, deposited by these supersonic winds, and turned into stone, and then solidify as mountains later on, a bunch of days or hours later, after the charges have finished doing their work. Poof, you have a brand new mountain range because of the electrical forces that are going on. And make no mistake, when this flip happened, there was some major thunderbolts being thrown around.
Oh,
yeah. Well, I mean, the only thing that could have made the globe flip, I think, is, well, only two things. Is a shift in the magnetic field that could have physically made the globe flip from north to south, or a body that's larger than the Earth, with a larger magnetic field than ours, oriented in an opposite direction, or maybe even not even necessary for that to happen, coming close enough to the planet to physically flip the globe itself.
Do you have any idea of how long that process took? I heard like it took 5 days, or no more than 5 days.
Well, if Squatterman lasted 3,000 years.
No, I'm talking about the.
No, I'm just saying these events happened very quickly, is what I'm trying to get at.
Well, everything went in phases,
Well, if the Earth flipped, it flipped fairly quickly. You've seen the video of the T-handle in space flipping, right?
no.
Oh, well, there's a video of a T-handle spinning in space on, the Russians have a video of this, and it's just sitting there spinning, and then all of a sudden it flips direction. And then goes back to the other way, and then back to it's wild.
Oh, I'd like to see that. That's a real video?
Yeah.
I haven't seen that.
Yeah.
It's on YouTube.
Oh, I'm going to have to find that.
I just think about that shot though. That all the pyramids are north south aligned. So if that did happen, it happened before the pyramids were built. Well, that's one point about that.
Yeah, I heard, I read, I think, from John Cook that pretty much all the pyramids went up within the same 100-year period. You heard that?
No, that makes sense to me, though.
They all went up about the same time.
Well, I think the pyramids were built before the Day of the Centipede.
Day of the Centipede? What day?
When Anubis called on for the centipede to kill everybody.
Ah.
Yeah.
I don't know that story. Really?
I never heard that story, man.
Hang on a sec.
Where are you getting that shit from?
The Egyptian
I never
scroll.
heard that story.
I'm just
Really? So why did he do that? What's the story? Why did Anubis want to kill everybody?
Yeah. He just got a mean seed in him.
As the story goes, probably because everybody had gotten evil,
Oh, you're okay.
Except the centipede god of Egypt.
I did not know they had a centipede god. I did not know that.
I never heard that either, man. That's pretty crazy.
I mean, I know the beetle. I know they're into that, but I did not.
Great centipede.
I know that. Wow.
I've been busy.
I'm looking for the quote. Hang.
Very interesting. I mean, that's how come I don't know that? Like, weird.
Yes.
You
Weird, I
things
should know
are
that.
always changing, man. They're always changing. Nothing stays the same.
All right, I found it here.
What did you find there?
The quote goes, "I am Anubis on the day of the centipede. I am the bull who presides over the field. I am Osiris, for whom his father and mother sealed an agreement on that day, carrying out the great slaughter. Jeb is my father, and Nut is my mother. I am Horeth, the elder on the day of ascension. I am Anubis of Sepha. I am the Lord of all. I am Osiris." Now, carrying is sealed in agreement on the day of carrying out the great slaughter. That is the day of the great slaughter. They're talking about when the great flood happened, when the earth was formed in the eyes of the biblical people. That is the day of the great slaughter, the day of the centipede, when Squatter Man was at its height of power, when it was throwing out all kinds of synchrotron radiation. It had multiple segments, like we see the rock art showing all of the ladder of heaven and all of that. That's Squatter Man, and in it's one of the many forms, as Anthony Perrette shows in the lab. These small, very small discharges, they change very quickly, and they've taken video of it, and they've documented how they've seen the changes. They watch how it changes. But there's other things that they don't have in the lab that were around, like other planets that were around, that causes changes to the way it looks. So it's not going to look exactly like it was in the lab, but it's going to be very close.
Right.
Because everything is scalable.
Cool pocket. And, be cool. I want a Butterfinger and a pop. Okay. Sorry.
I'm gonna have to reboot. I got a problem with my mouse again.
Nathan,
Keeps going down to the bottom of the screen, so I got to reboot. I'll be back.
Okay.
Everybody's having problems with their computers.
No, my kids are going to the store looking for everything, and just I don't know. Had a moment there. Everything's cool though. I'm trying to
candy bar and your soda.
Huh?
You're gonna get a candy bar and some soda?
Yeah, I'm getting me a Butterfinger, man. I like those things. They're good, man. The peanut butter.
I haven't had one of those in a long time.
I know. I try to, I got a 15-year-old in me that I nurture every chance I get.
I don't know when the last time I had a Pepsi.
My wallet is in my coat. If it's not, then I don't know where it is, because that's where it's supposed to be at all times. Man, you're blowing it here. I'm a star. I don't talk like this. Okay.
They don't care.
My dirty laundry here. No. I'm trying to accomplish something. I noticed something in space not that long ago, and
what?
Well, I'm accumulating the photographic evidence before I say it. So just keep talking while I look. I'm trying to find the doggone thing. Of course, I was tripping over it all day.
This is something you found.
Yeah. I found it. It's one of my favorite nebulas, There's a couple of them, actually. It's pretty freaky. I'll have to show you, because if I say it, you'll just think I'm weird.
So.
No, I won't think you were. You know, I think I might know what you're talking about.
Okay, there's one of them. I found one of them. Okay. And then I just got to find the other one now. And
The Oob Chronicles will start.
I'll be able to show you what I'm talking about.
I'm back.
The other one. Yeah, you guys chat up for a bit. I'm kind of engaged here.
You know, there's this website. It's called the Zoo Universe, Zoo Universe, or Zooniverse, or something like that. Anyway, it's you get on there, and this is your average Joe, anybody, Joe Public, whatever. You have a computer. They give you you learn this little program. They have this way, and they want you to find and catalog galaxies for them. And they give, from all these different snapshots that have been taken,
Not
whatever.
Black Hope.
No, man.
I'm sorry. Go ahead. They can't find my wallet. I mean.
Well, you lost your wallet.
No, they can't. There's no way I lost my wallet. I didn't go anywhere.
Look at the couch.
Oh, you guys, man.
On the ground, under your bed, by your nightstand, something.
Look on the bed. Maybe it was like.
Where was the last place?
Laying on the bed.
Yeah, I'm thinking it definitely was on the bed
Yeah.
before you went to bed.
Yep. Because he wallers all. Just all you gotta do is lift up the blankets. It's probably right there. Okay, now I'm getting back to my conversation. Just find it. Okay, sorry guys.
Well, your wallet's important, so.
I know. I can't
Why is there a piece
believe
of
it. I
pizza
just,
on the floor?
it's always
And some people, are better.
This is a half-eaten piece of pizza. I told you to stop talking, you fucking boomer.
You're going to have to go find it.
The last time we used it, you went grocery shopping. You went to the market and got that lasagna.
Man, you put the card away in your wallet.
Yeah, well, I always put my wallet in my black coat. I don't know
Yes,
why it's not
but where
there.
were you when you put your card? When he gave you back the card, where were you at the time?
In my room. I put it back in my wallet and put my wallet in my coat.
In your pants? No, I don't know.
Drawers, man.
No, man, I wear
Greg, there's-
jogs. I don't wear jeans. I don't put my wallet in my pants.
Greg, there's a couple of things you shouldn't share, and your wallet's one of them.
Yeah, I know, dude. But I mean,
What do you
if
like?
they're just running up to get some cat food or something, ain't so big deal.
Yeah, I know.
Then you should have a different place to put it. Put your wallet, like, in the middle of somewhere.
What's happened is
Doesn't work poorly with our mails.
What's happened is it's fallen. It was sitting on something, and it's fallen either under the bed or.
That's what I said, under the bed or.
It's here. I know it's here. It's got to be here.
I mean, where do you put your coat? You put your coat on the floor?
No, my coat is. No, I have my coat in in the living room, hanging up in there.
Like hanging on a thing. You don't put it in the closet or
In the
anything.
closet, yeah, or I just hang it over the couch because it ain't gonna be long before I gotta put it back on and go out again.
I said the couch, man.
The way I get my balls busted constantly. But I'm trying to figure out what the hell. Now, last night I'm drawing a blank here.
This is a
You know,
daily
we were
thing.
just getting into some good. This is just my luck. It'll be a damn wet blanket. But I gotta find it. I'm gonna put myself on mute. You guys get to visiting, and I'll just come back when it's found. I'm distracted here. I'll take off. I'll be back. You guys just keep the party going. Thank you.
There's a lesson for me. Keep your cash in your wallet and keep some cash somewhere else, just in case you lose your wallet.
Shockwave, back to what you're on about. Shockwave's back, isn't he?
Yeah, I'm here.
Cool, mate. Let's get back to what you were talking about.
Yeah.
Greg will catch up.
You were talking about
Claudia's coming.
Waterman.
Yeah.
You need one of those tile things. You can.
Might work, Paulie. Might work, Paulie. We'll be emailed. Winning.
Did you find it?
In the car.
I wonder where it was.
I think they found it.
Yeah, I have to know where it was.
Okay.
What were we
Where's everybody
talking
going?
about? I don't know.
We were talking about Squatterman. You were talking about Squatterman.
Oh, yeah. It lasted 3,000 years. In a laboratory, it lasts split seconds. So you tell me.
How gigantic it is.
Difference.
The difference in the scales. They don't see it. The mainstream scientific community doesn't see the fact that these events are scalable, and we can test that in the laboratories. We can do experiments and show how craters are built and all kinds of other phenomena that shows that the universe is electric, but these people just won't pay attention to it because they think it's stupidity. Comes from Manuel Velikovsky. I mean, it's ridiculous, these people.
And I keep thinking, well, maybe, waiting for these people to die off, but they keep teaching the same stuff. So it's like, I mean, how long does it take for?
Well, there is hope. There is one of the lead people at CERN has looked at the electric universe and has seriously looked at it. So,
and these the vortex lines, and that it's sort of elementary use in the universities, but it's still describing what we see. The we look at the stuff. So that's up to us.
But I mean, scholars are too invested, and even if they know it's wrong, they have to
as well.
stick with it.
I've seen these lattice shapes, and if you put balls that are sort of the same as atoms, if you start stacking lattices of them, you've always got a shape in between the balls. And this is probably where the exotic vacuum object can stop. Possibly, this happens in chemistry. I think it goes along with the atomic theory that we like as well, the structured atomic model. So yeah, let's go for it. Yeah. They're popping up in every area that we're looking at now in astronomy, and it's explaining things that gravity doesn't. So we've got to keep this line of inquiry wide open.
Okay, I want to know why you say 3,000 years. Why it took 3,000 years? I mean, could it not happen quickly? How many people do you have over there?
I think it depends upon what scale the manifestation happens. You get these massive void areas in the in the galaxy, don't you? And you don't know what's in between the galaxies, really, in terms of matter, apart from the Birkeland currents. So, these voids might be packed full of it. Who knows? Yeah. Mainly power.
No, we're here. It was your turn to have a bit of a start, Nick.
Yeah. All right. No, that's about it really for now. I think that's all I want to talk about.
Greg is going to show us his.
But they are showing up in every area of our inquiry now. Of course, Buddy's onto the same thing with his artwork, and plasma seems to be behaving in these. It's manifesting the same shapes as these structures, the vortex structures, and these are shown in the experiments. They seem to happen at all scales. So from probably cellular level scales up to our level scale, up to Earth-size scales, planetary scales, up to stellar scales.
God knows how big it could be huge.
And beyond. On every scale, they seem to manifest, don't they? So
it's how everything works.
They behave like standing waves, solitons. They don't seem to be affected by other things that affect time as we observe them. So we've really got to find a little bit more about the speed of light as well, in my view, because that isn't closed at all.
I agree.
There's
Greg, are you going to the nebula? You said really.
Yes, I'm still trying to dig up that second picture. As soon as I find it. I found my wallet. It was underneath my chair.
It was under your chair.
Yep. It's the first place I looked. There it was. All right, I'm going to find the picture.
Under your chair. I knew it was under something. Okay.
Well, it's thoroughly rated, fellas. Is the show still going on there?
Yeah, keep checking. Yeah. I'm trying to find this thing. It's really cool. I want you guys to see it, and I'm gonna show everybody else too. What I mean about phases change.
Probably.
Mute myself.
Nick?
I'm back. Sorry. I was talking with Gordon and Jay Pershing in the chat, and yeah, EVOs basically are plasmoids, and highly energized plasmoids will penetrate through any material. I mean, if you took a pane of glass and ran it through, if you could physically run it through the center of our galaxy, through the plasmoid that's at the center of our galaxy, when it got to the other side, there'd be a great big hole in the middle of it. Pretty much. I mean, anything that goes into the central plasmoid of, as they say, in a black hole, everything gets ripped apart.
Now, okay, plasmoid, black hole. Okay. It's what is this? What is the center of our galaxy then? Is it a plasmoid?
Yeah.
And
it's a Z-pinch, and that Z-pinch effect will create a plasmoid when it concentrates all that energy into that one little point.
Right. And so okay. How come it's not a black hole?
We're circling a plasmoid, basically. The sun is a
yeah,
plasma, a ball of plasma, a sheath of plasma with a gas giant at its core. And it's, I mean, again, you take a pane of glass that's big enough and you run it through the sun, what's going to happen? You're going to have a hole in it. Right? This is what we're talking about. We're talking about highly energized electrons that'll just rip anything apart that it comes in contact with.
Wait a minute. I'm just trying to think of then what, like if that's in the middle of our galaxy, then there must not be anything, nothing can be close to it, or, I mean, how far away?
We see from images that they take of even moving images over time that they've taken of the center of our galaxy, they see stuff orbiting the center, and they call it a black hole, right?
Yeah.
But it's not a black hole. It's the center of the plasmoid.
Right. Right.
So is that sucking in matter, or is it doing both?
What's that?
Is that at the center of the plasmoid? Is that pulling stuff in,
Think about a Birkeland current, right? And a Birkeland current has multiple shells of counter-rotating drums.
Yep.
Right. Now you pinch that down in a Z-pinch. On the largest scale, you create a galaxy. On smaller scales, within the galaxies, you create suns and stars and planets and things like that during these electric discharge events, with lightning bolts that are hundreds of light years long, even thousands of light years long, creating suns and planets and smaller suns like brown dwarfs and all kinds of different sizes that, because of the electrical force, congregate together. Gravity's got nothing to do with that, with matter coming together. It's charge that makes things move in this universe.
I agree.
Looking at the chat still, Shockwave a bit.
Did Greg? Did you find your pictures?
Yeah. I got it. Okay, I want to show you. I wish I had a better one, but you get the point here. All right. Things are always changing. Nothing ever stays the same, and it comes in phases. Even with the nebulas that we see in space, they're constantly changing. This is one of my favorite nebulas right now. It's called the Eagle Nebula. Why they call it Eagle, I have no idea, because it looks like a princess.
I see why.
Looks like a princess with like some wild-looking pet to me, but it's the Eagle Nebula. You see what I'm saying here? There's her face, and you see, this is the changed one. Here's the one that has been. No, that's the changed one. Yeah, this was her like about a month or two ago, and now you can see how much it's changed. Now it looks like some guy with a couple of pigs.
And the other ones aren't?
What?
How come like this one is? Shouldn't they all be changing all the time?
Of course.
They all are,
yeah,
but But we're talking about cosmic scale time. We're not talking about human scale time.
That includes the one we're looking at. And he said that just this thing has changed in a week.
In the last couple months. Yeah.
Or month or whatever.
Months.
But I mean, that's
isn't that freaking? Look at that. She's like diamonds for eyes and these creatures.
Well, it's going to take us. It's going to take us. It's going to take us years and years and years of observations to understand how slowly that things move out there. Mm-hmm. From our perspective, we're looking at a gas cloud that you could fit.
But anyways,
a billion of our solar systems going in a line across, or more even. I don't know. These structures that we're looking at through telescopes are massive.
Massive.
Absolutely.
Some of them can be bigger than our galaxy even.
Oh, absolutely, yes. They could be light years long. Yes. I just think it's cool that they always seem. See, here's the girl that it's supposed to be. Whoever this girl is, who's this? Oh, never mind. I thought I put it in there, but I didn't. Who is that? The girl with the wand. Is that the girl from what's that? Disney or something? I don't know. That's who is that? No, that's not the one. All right, never mind. I'm gonna just find that other picture because this one here is really good too, but it's even better. Oh, come on. Guys, you can talk while I'm doing this thing.
Yeah, Shockwave. You check. Oh, yeah, you have. Yeah. I was just asking if you kept an eye on the chat. That was all.
Oh, yeah, that's important. Yeah, thank you.
Shockwave is a great name.
Yes, it is. Yes, I thought of that too the other day, Paulie. I thought, damn,
that's
man,
a great
I'm always here. I'm always reading Shockwave, especially in cosmology.
I mean, just saying the word shockwave, it just it wakes you up.
Yeah, I know. It's pretty clever thinking there. Yeah.
It's also a really bad transformer too. I'm totally into Transformers, so.
You are?
Oh yes, oh so much. Oh my God, I love Transformers.
Look at this. You see, I've always thought that icon up on top of that nebula looked like Lucy from Peanuts. Now she's got stars for eyes, so that's Lucy in the sky with diamonds, right?
It looks like a girl.
Yeah, it looks like Lucy. Her black hair and her little... I've always said that. What's Lucy doing on top of that?
She's got a bird on her shoulder.
Well, I'll show you a better picture. I got a better one. Now she's got freaking diamond eyes or star eyes. She never had them before.
Oh, look at that one. That looks like somebody's from behind, like the back of somebody's head.
Hold on a second. Yeah.
To me, it looks like somebody holding their arms up to their throat and looking up in the sky, but the face is not really, let's say, normal. It looks like it's been beaten in.
I like to think that it's the back of their head.
Well, you can see the mouth open. It looks like it's open, and then the nose is missing, and the eye is like there's a pizza slice depressed in the face. It's nice to look at these pictures and see, what you can make out of them, but they're just pictures of gas clouds, folks. Come on.
They're nebula. They're plasma. Your boy there from Thunderbolt says dust and gas. Says no, it's plasma. There's another one right there.
Yeah, of course.
I know, but check it out, man. Now you see what I mean. Of course, it's not. It's pareidolia. But it looks like freaking Lucy. There's her head. There's her hair. There's her little freaking dress. And she's got stars for eyes. So Lucy in the sky with diamonds.
And those stars are actually look like tears coming out of the other eye, but that's okay.
Yeah, that is
Yeah.
just so cool. Look, I mean, whether there's something on top or not, there's stars up there, obviously. So stars are being born in this. Is that
Well,
what it is?
it would take an electric discharge within the cloud to pull material together to then create a new sun or solar system or line of solar systems or line of new stars. But it would take charge to be moving through this. Obviously, there isn't at the moment.
Of course, yes. Nothing can exist without charge.
Yeah.
I mean, that pretty much goes without saying, I guess.
It's the universe. It's how the universe works. It's charge, the opposition of charge, and the potential between like charges also has an effect on charge, on a charged object. So there's all of that charge influence that the mainstream doesn't take into effect in cosmology. Just gravity and mass. That's all it is.
Well, that gas cloud does have a presence about it. Especially the pink one. You know, see the rays coming off it. That was a good picture, Greg.
Yeah, thank you. I loved it when I saw it.
Yeah.
I'm a visual kind of guy.
But I think it's they tend to take on animal forms or forms that we can comprehend and understand, don't they? And as the clouds drift along, they assume different shapes. And whatever's in your consciousness, they will fit to it. I think that's what happens. Well, that's what they do. I mean, this picture, of course, it's lovely. It looks like some kind of animal farm somehow, doesn't it? I don't know.
Exotic pets.
But things do assume a shape that you can really relate to. It looks just like it when.
It's just amazing, yes. That's for sure.
Sometimes you can defocus your eyes somehow, and things start appearing as well. Sometimes, probably not easy to do on a screen.
So what are you looking for now?
Let me hear what you guys think about the whole Pelasgian thing. Do you think?
I think openly.
Do you think
that's what I think. Sorry.
the first white people?
Oh.
I think they were. I think they were the first. They were the first of the more civilized, the settled Europeans after the Ice Age. I think they had societies before other people in Europe, and maybe followed the ice northwards.
Wait, I think way back. Sorry, Gross.
Originally part of the. I'm not sure. I don't think they were the same as the Greek tribes because they seemed to be further north in the Black Sea, didn't they? Or even up near Crimea originally.
They came from the Ukraine,
sort of places.
A place a place that the Sumerians called Arata.
Yeah, Arata.
Go ahead, Gross. Sorry to interrupt.
Yeah.
No, not at all. But it seems like the Pelasgians were they had a war with Osiris, didn't they? But they first originated the Greek pantheon before the Greeks did. That's the oldest of the Pelasgians. For example, Saturn was probably a Pelasgian king. This is a theory, and he actually had a war with Osiris. So that's part of the I'm sure you know about that, Greg, don't you? That's part of the Pelasgian myth.
Yeah, they didn't just pull those names out of their butts. They named them after something.
If you go back far enough in time, if you go back far enough in time into the Crimea, in the Ukraine, you will find that the stories of beings falling from the skies came from that area. And the ones that survived were smarter than us. They had elongated skulls, and they brought civilization to humanity. They started mixing with humanity. At first, it was a law that they were not to mix with the black-haired, black-eyed people, but that happened. They created the white race. They created the Aryan race, which then in turn moved down off of the places where the ice wasn't, and they basically brought civilization to the rest of the world. These Pelasgians, yeah.
I think so too.
We know. I mean, we hear the stories of the Bible, the fallen angels. That's the same story, just changed around. We know the Bible did that big time. They've taken older stories and they've put their little spin on them, and they've changed the name to protect the innocent.
They were making steel like 2,000 years before Egypt. There seem to be the first steel workers in the world, really, that we know of. I think they had forms of writing as well before anybody else. How far they seem to live in the lands vacated recently by the Neanderthals. And they had a very kind of wild pastoral existence. Very didn't farm too much as just harvested the wild stuff and encouraged a bit of this to grow here and a bit of that to grow there. Had trade routes set up all over the place, and were very influential, really. That the Vinca culture right through Romania, they've got stuff older there than just about anywhere else. So as far as European settlement went, incredible. So the Pelasgians, they were certainly very influential, and like you say as well, wherever these red-haired giants showed up.
Well, that's why they call them the Indo-European race, because they were spread out all over the plains of the Urals. They're basically the Russians. They mixed with the Mongol races and became Russians. They mixed with the Indians and they became the Northern Indians, the lighter-skinned Indians. They mixed with the peoples in down in Egypt, and they became the Egyptians. They mixed with the people in Samaria, and they became the Sumerians. This is how it went.
I suppose they seeded their population with the local women who they met, I suppose.
The origin of the Oracle of Delphi comes from the Pelagians, right? It was in your video, Greg.
Yeah, it does.
But I didn't hear anything about
Well, the Palladians were an offshoot of the Hyperboreans, or the Hyperboreans are an offshoot of the Palladians, and the Hyperboreans brought the Oracle of Delphi to Delphi,
I see.
right?
Okay. Starting to make sense now, you see. Yeah. That's why I like these pelasgians, because ever since I picked up on them, I've been reading a lot of good stuff, and you know, you pick up a little bit here, you pick up a little bit there. It's funny, the people who were of higher class, they were called parte. Well, that's party. That's where we get the word party.
Yep.
So,
And what do the elite like to do now? Not follow the rules and do their own thing and partay
Yeah.
Partake.
with our money.
Yep.
So, what were they called? The conehead, you know, the elongated skull people. What was their name?
Kings and
No, I mean,
priestly
you know,
kings.
what was they had to be named. They had a name for their, you know, what their
Coneheads.
for. Did they have, you know, what were they called? I mean,
Coneheads.
Well, when they were called the priestly the priestly king class, and they were considered human just like us because they had arms, they had legs, they had fingers, they had mouth, they had they had all the things that we had. But they didn't realize after time that they came from a different world, like
right.
Mars.
But I mean, they must have a name for like who they are. Like, you know, like we call ourselves humans, they must have called themselves something, or we're, Aryan or whatever. You know, we have.
No, Aryans are the race that they bred into
but
existence.
I mean, they must have had a name for what they called themselves as a group of people. What I'm saying. Just that got lost somewhere.
Well, nobody knows. Maybe that we might find that in the Paracas cultures somewhere.
Yeah.
Because that's where the last of them survived to. They moved there and were finally wiped out 2,000 years ago.
Do you think they were wiped out, or did they just go home?
No, they were wiped out. Well, go home. They're not going home to Mars. They don't have the technology.
I think most of them. I think they've successfully the populations before the sort of the old lands, the older lands got wiped out. But I think they've successfully, mixed with whatever they were mixing with.
Oh yeah.
Another thing to say about that.
Think about the 13. Think about the 13 families that control the world. They're descendants of these people.
Right, and they do, or I've seen things about, they say that some of these people, they do have elongated skulls, they just hide it.
Hey, Paulie, have you ever heard of the Fakawi tribe?
No, I have not.
Yeah, they walk around the desert and they say, we're the Fakawi.
We're
the Fakawi. Oh, no.
But I mean, if the elongated skull people, if they were the ones that like created all the different races, then all of the different races, there would always be like, I don't know, one out of 100,000 would be born with an elongated skull. I mean, that trait would be there because
I think they were a different species.
People are born with 7 fingers. There's actual people that have been born with 2 rows of teeth.
Right. Right.
There's actual people that have been born with horns on their head. There's a lot of genetic
I know, that's what I'm
you might say throwbacks.
Born with like elongated skulls. I mean,
there was a little girl in the news recently, and she'd been born with a horn on her head, a massive big horn crust, and they removed it anyway. It was I don't know if there was skull underneath that, but it was like she almost turned into a lobster.
Ew.
Weird, really. Quite weird. What can happen genetically to you? I think she was a Romanian little person.
Yeah.
They've done an operation on it, because they tend to do that, don't they?
Yeah. So are they? Did they have red? They had red hair, right? Didn't they have red hair? Or mainly they were like, they were they were ginger type people. The elongated skull people. They were.
Yeah, they had red hair. They had red hair and red eyes.
Red eyes, really?
Yep, auburn eyes.
Ew.
Well, you have go look in the mirror, Polly, and see how much red fleck you have in your eyes. That'll tell you how closely you're tied to those people.
I've got a lot of yellow in there beside the blue.
You have a lot of red fleck in your eyes? I don't think I have red fleck in my eyes.
Yep. Go look close. You'll see little flecks of red here and there. If you have a lot of DNA that is theirs. Are you Rh negative? I think you are, aren't you? Polly?
I don't like that. I just looked.
Did you?
Yeah, I have a lot of red flecks I never even noticed.
Yeah.
Yeah, probably see a leadership class after all.
Which is that's kind of trippy.
We're sorry, but
It's not trippy at all. You're our race, the Aryan race, the white race of North Europe and Europe itself. We're born from coupling of these fallen angels and humans, the black-haired, black-eyed people. Period.
Oh, like black slime?
Black-eyed.
Black goo?
No.
So the
Black,
people,
there's people that populate the earth right now that have their genes express black eyes and black hair.
Oh.
Those are the
I see.
basically the and that's worldwide. Like a lot of black-haired people, black-eyed people around the world, and those peoples were not messed with very much. Their genetics changed to match the electric environment that we live in now, along with maybe a little input of these people, because they moved around the world. They didn't stay in one spot. They spread around the world, and that's the story of Atlantis. That when Atlantis was destroyed, 5 or 6 people from each of that Atlantean tribe went to one place, and another 5 went to another place and spread the culture around the world.
So
That's the story.
Are you saying
Right?
that Atlantis is actually Mars?
No, it's
Well, they're from Mars, right?
And some people do.
Somebody said they're from Mars.
They watched North America get devastated by a thunderbolt hitting that side of the earth.
Oh.
All the way from this side of the earth, they could see what was going on because it was so big. Like
Yeah.
a lot of the mountain range, the Canadian Shield, was etched away, gone, ripped out.
Oh, the landscape was totally changed. I mean, but okay, so they're originally
People that were there, what crap? I can't remember the name of it. It starts with a C, and they were alive with the mammoths. Oh my God!
starts with a C. Can't.
Yeah, the Indians that were there's a layer of dark mat in North America. There was life below that and life above that. Nothing in that dark mat range, and the Clovis people.
Yes, I was going to say.
They
Yeah.
were incinerated.
They were wiped out, completely wiped out. North America was devastated from the
That's about it.
from North Bay all the way down to almost into South America, and I think South America was heavily devastated too at that time, because we know that Teotihuacan and places like that were thrust up 6,000, 8,000, 12,000 feet from where they were, which was about 3,000 feet above sea level at one point.
Wish somebody would make this, just to show. I don't know. I just would love to have a visual.
Oh, it would be the best movie ever made.
I would just, oh. And that, that would also cause tidal waves and all kinds of stuff too, right? Yeah.
You bet.
And that would cause earthquakes too, wouldn't it?
Mm-hmm.
I mean,
And volcanoes.
And make.
Well, think about this: if Saturn is depositing this massive amount of water on Earth, what do you think it's going to do to the atmosphere that it's going through? It's going to push it aside, for one, and it's going to let the cold of space come down and touch the surface of the Earth. Basically, instantly freezing shit, which we see evidence of in the north, right? So, with a lack of atmosphere and being electrocuted and being frozen in place, how do you think the ice cap formed? I don't think the ice cap formed, I think it formed instantly with all of this water coming down.
Totally agree.
A lot of it, I don't know how fresh water, if it's all fresh water or what, but something happened very quickly to create that massive chunk of ice on the northern hemisphere of the planet that was there.
Yes, that was tropical, a tropical place.
Yeah, and I think all the ice accumulation and depths that we see now are just not years, but they're storms. Each storm that runs through puts a new layer down, not each year like a tree ring.
Right. I agree.
So that all that snow, all the ice cap that we have nowadays could have accumulated after the massive melt that happened up there when the second event happened and melted pretty much it all. Because we know there was more than one event. We know that there was more than one event. Velikovsky says there was 2 or 3 or something like that. And then so Peter Mungo-Jupp sees 5 events in the layers of the Middle East. Go ahead.
Yeah, but that doesn't mean that they're spread out thousands of years apart. They could be, from the same storm.
Civilizations rise and fall because of these events. So there has to be a lot of time in between them.
Yeah, I guess.
Velikovsky talks about planetary ages instead of solar ages. One age is the age of Mars, one age is the age of Venus, when these bodies were causing problems to the Earth. Another age was the age of Jupiter. Another age was the golden age, the age of Saturn, that humanity grew up in, enclosed inside a brown dwarf star's outer glowing sheath, providing moisture in the air all over the globe, heat constantly radiated. It's the same temperature all over the whole globe. There's no way there could be an ice cap.
There's no bad radiation, right? It's shielded the bad radiation, so
it's shielding any cosmic radiation that wants to come in. This plasma sheath, just no, you can't come here.
So nobody would really get sick
or age very, very quickly. Yeah.
And so okay, so I want to know, like, where did like us the black-haired people, they were on the Earth, right?
Yeah, they were indigenous to the Earth.
This is where they came out and they evolved or whatever. So they were like the original people from Purple Dawn.
Well,
That's a good question.
I think humans advanced to the point
Pelesgians,
of
maybe.
Cro-Magnon, not Cro-Magnon, Neanderthal.
When
to
you
that
were a
point.
kid, didn't you always feel some kind of like it was when it was blue outside? We call it the blue hour, right? Because no two are ever the same. There's this some kind of an enchanting feeling that comes with that. It's almost like it's a reminder.
You mean dusk?
The blue hour, yeah. There's one in the morning before the sun comes up.
That's my favorite time of
Oh,
the day.
I love that. It's enchanting, and I think that's almost like a reminder of the purple dawn. That's how
Maybe.
I feel about it. You know.
And then what are these pictures of you're showing here?
Oh, this is just I'm just showing a slideshow. I changed it so that they're not bored to death with all the same shit. You know.
Well, when you said that, that was a Greek helmet.
Yeah, well,
Probably
that was
Trojan.
actually a Pelesgian helmet. Yeah. Mm-hmm.
Looked kind of Trojan.
Mm-hmm. Well, that's what I'm saying. The Pelesgians were probably the ones that came up with Zeus and frickin' Kronos, and it was got stolen by the Hellenes. Because the Hellenes came and they're, the Pelesgians were with Troy. Of course they were, because the Hellenes were taking their home. The Hellenes, they were bringing hell with them. That's just my opinion. But they're not indigenous to Greece.
Kavala.
I think they were the people of the sea.
The people that came and warred on everybody else in Egypt.
Oh,
and stuff,
yeah,
and
like there were these people in Crete. I don't know if you ever saw this program that I saw. I probably did it. It's pretty popular. They found out that these people had abandoned the city and went up in the mountains where they had to freaking walk these real perilous ledges and shit to get to it because they were hiding from something or someone, and I think it was the people of the sea who were going around robbing and ripping, and raping,
Wasn't that around 1500 BC?
Somewhere around there, yeah.
Yeah, well, what else do we know that happened around 1500 BC? Oh yeah, the Exodus,
Mm-hmm.
the
was all just like every man for himself.
The parting of the Red Sea when Venus flew over, and what else happened around 1500 BC? Oh, Sodom and Gomorrah. Mm-hmm. A lot of things are starting to come together that happened right around the same time, and we know that Venus was responsible for. Because Velikovsky's been telling us that Venus was responsible for the Exodus, so it had to be responsible for all of the other things in that area.
The one part that freaks me out is where did that freaking manna come from? I mean, it saved their lives, right? They would have never made it without it. Every day there's manna on the ground they could just eat.
It came from the tail of the comet.
They were so wild, man. That's so
they were
crazy.
complex hydrocarbons.
Uh-huh.
Man can eat complex hydrocarbons. We can't eat regular hydrocarbons.
The next time it came by,
it's like
instead
oil
of
or gas.
It was delivering burning oil.
Mm-hmm. Fireballs from the sky.
Yeah.
There's legends and the Bible's replete with it.
There's something too about it saying that it had a really sweet odor. It had a sweet smell. I remember it.
Manna? Yeah. They had, for it to be edible, they had to bake it. They had to let it dry out and then bake it.
That's pretty amazing.
I think it's probably more a mushroom spore by the sound of that then. I think it could possibly a fungi, yeah. That might have come, spores come down, maybe. The fungi. Don't know.
What are you saying, Nick? It's hard for me to hear you. You got kind of an echo going on with your voice, and it's hard for me to distinguish what you're saying. What'd you say? Do that again.
growing some kind of mushrooms, fungi.
Mushroom, yeah.
That sprouted up. Yeah.
Well, there's good fungi and bad fungi, right? Just like bacteria, right?
Yeah.
Because some mushrooms you can eat, but others you can't. I mean, I don't know who the first guy was that decided that, he found out.
Well, there's someone's a sucker.
Might not have been very good.
Well, maybe it was. This mushroom. This looks good. I'm gonna eat this, and then he just ate it, and he was fine. And then he come across a different mushroom, and he ate that, and
Yeah.
But I mean, there's someone's got to die.
well, he ate that one. That one didn't do nothing to him, but that one did. Stay away from that one, boys and girls.
Well, now on bugs, if they got red on them, leave them alone because they're poisonous. So maybe mushrooms are the same way. Maybe they got colors and shit.
Not really.
No?
Some do.
Okay.
I wouldn't take my chances though. And I mean,
Some of them are brown, some of them are white, some of them are yellowish.
Yeah, anything that's grown in shit, I'm really not interested in it. I'm not. No thanks.
Well, I don't think they're grown in shit. They're just grown in wet.
Yeah, they are.
That settles that.
Yeah.
Where do you think the saying "treat me like a mushroom" came from?
I don't know. I never heard that saying before.
What do you
my
think
God.
about that theory that says that all these mountains used to be trees? Have you heard that theory?
Oh yes. And some people have gone way out of their way to
I know.
dedicate
Don't
themselves
they
to this.
always? Yeah. Right.
Everybody treats me like a mushroom. They keep me in the dark and they feed me bullshit.
Yeah.
That's a good one.
Next time, instead of falling in love, I'm just gonna find a bitch that I hate and buy her a house.
Don't be like that. Don't be bitter.
I'm just kidding. No, somebody else said that. I didn't say it. I can't remember. I think Jim Carrey said it or something. I thought it was funny.
I never heard that before. That's great.
Yeah.
No, that's one of Rod Stewart's favourite sayings.
Oh, is that what it is?
Buy a woman you don't like. Yeah, find a woman you don't like and buy her a house.
Yeah.
Got memories, bought a few.
Remember Little Miss Muffet sat on her tuffet with her bowl away. Along came a spider, sat down beside her and said, "Hey, what's in the bowl, bitch?" The dice, man. Oh!
Yeah, Andrew Dice Clay.
Yeah.
Was that Andrew Dice Clay?
Yeah, that was the dice, man. Yeah.
Whatever happened to him? Did he die?
No, he's still alive.
He's still around, yeah. He went through some hard times. He was stealing a lot of his material from Bill Hickey. Remember Bill Hickey?
I do.
He was a comedian. He got cancer and died young because he was talking about the Kennedy assassination. Anyways, he was stealing a lot of his material from someone and he got caught. I heard about it.
Wait.
Pauly Shore was one of the guys that figured it out.
Pauly Shore.
Yeah, remember him?
Yeah, that's a real piece of work, that guy.
He was on some show. I don't know, little dude. Yeah, these big boulders, like it's on TV right now, these things got just like thrown for miles. You know, that must have been some kind of wind.
Yeah, over here where I live. I mean, you drive on the freeway and you look out over, it's kind of like rolling hills, or just rolling hills with trees, and places of oak trees here and there.
Yeah.
But there's just these giant boulders, just scattered, just random, scattered all over the place.
Imagine when those things
trips you
started
out.
landing. Yeah.
Some of them are just huge.
Yeah.
You know, it's like, what?
Well, that's what supersonic winds will do to a object. It'll pick it up, and it'll just chuck it wherever it wants to.
You know, and I was like trying to point this out. I was driving. I'm going, look at how strange it is that just these boulders like come just out of nowhere. Something exploded or something. You know, something humongous happened.
Huh.
So, sir.
You know, is really the thing that gets me is that even on the highest peaks of K2 and Mount Everest, there are sea fossils.
Yeah, giant clams. They're giant too.
And that boggles the mind. How in the world could that possibly?
Andrew Hall explains it, bro. Go watch some of that, some of his videos. Why are you asking the question then? You should know.
About him lifting mountain ranges. And,
oh yeah. He talks about that all the time in his latest videos. He's showing you.
I haven't had a chance to watch for a while since he did the dragon thing.
I mentioned it earlier before. North America got devastated. The Indians in the Mahabharata say that two groups of peoples were wiped out, by the gods, by the weapons of the gods. They saw from India the mushroom cloud that was created by the thunderbolt hitting North America. It was completely devastated North America. It wiped out the Clovis people. It wiped out all the animals that were there. It took a long time for North America to become repopulated. Peoples moved up from South America that survived and repopulated North America. A lot of that happened, and then there was a lot of mixing from, as Raymond shows us, from the Chinese and the Welsh coming in and helping repopulate the northern part of North America.
I did not know the Chinese were in North America. It doesn't surprise me though. They had those big ships. They probably traveled.
Well, I mean, what are Eskimos? Are Eskimos, or are they Chinese?
Yeah, well,
there's
a resemblance, I think.
Yeah, Ramon was saying the Chinese got us up to Cahokia as far as that, and went back again, left again.
Exactly. Where are you going now?
We're pushed out by the southern tribes.
There were 3 cans. There should be one.
Yeah, Grouch, they were pushed out by the southern tribes.
Yeah, I swear to God, dude, there was just like a tower of cans of cat food.
Yeah, yesterday.
How can they all be
I don't know.
Wrong,
I don't know.
Fuck that.
All right.
It's got your voice.
People have no respect. They're just rude. They're just, you know, I mean, they're just, I would never do that. Just
They're not aware.
No, if I wasn't on here, I would have took him down, but I just let it go. He just doesn't know any better. He's ignorant.
But you can teach them.
Yeah.
I mean, it's not like you weren't teaching them.
No, they already know everything. They can't be taught anything. They have to find everything out the hard way. So,
and that's usually the way it is for everybody.
No,
I could help you. I could save you a lot of pain and a lot of money, but you're not going to listen to me anyway. So just go on off and do it. Find out.
Me, I watched my sister. She bit it every second she was.
We can only teach them the basics.
Yep.
They have to figure out the advanced shit for themselves, just like we did.
Did you ever see that sign that says, "Dear teenager, why don't you leave now while you know everything?"
Yeah. That's funny. That is funny.
Yeah.
I know everything.
Hey, you know what? If you stick your hand in that socket, you're going to get electrocuted. What I tell you, you know? I mean, it's that simple. But they still don't want to learn. I mean, they want to learn on their own by themselves the hard way.
Everyone like that. I wasn't like that. I learned to watch my sister get spanked enough. Like I know what not to do.
I must have been weird because I listened to my parents. I don't know.
I listened too. I listened,
Strange.
and I didn't want to disappoint them, so I was very. Yeah.
Right.
I wanted to make them happy. So.
Right.
Come on, Greg, you goody.
Well, I stole my dad's car once when I was 14.
I stole my grandpa's car too once.
Did you?
I felt so bad.
Oh my God, I did too.
I went up to the gas station and I put like 50 cents in gas just in case, in case he noticed. I went like 2 blocks down the street.
Yeah, we went joyriding, and I came home a couple hours later, and he was sitting on the porch waiting for me.
God.
Oh boy! But you know what he did? He just said, "I'm glad you're home safe. Don't ever fucking do it again." And I never did. I felt bad. Because I know I disappointed him, you know?
Yep.
Yeah. That was really all it took for me.
It was odd for me when I did that too. I don't know what got into me. I don't know why I did that.
Mm-hmm. Yeah, me too.
And I was like, I couldn't get caught. I just couldn't get caught. Worst thing I think I ever did.
Maybe your parents trusted you. They trusted me. I couldn't betray that trust. If I did, I'd never be able to live with myself, you know? My dad was older. So as a kid growing up, I knew that, you know, I wasn't going to have the amount of time normal people had.
Yeah.
He was gone
the older
by
they
the
get,
time I was 26. So, so I made up for lost time by by just being there for him, you know, loving him. It's hard for me to talk about. I'm still getting broke up right now just thinking about it. It's hard. Losing your parents has got to be the freaking hardest thing that ever happened to you. You know?
Yeah, Mom went at 67, way too young.
Your mom died at 67?
Yeah.
What did she die of?
Pancreatic cancer, the most painful kind you can get.
Oh my God, yeah, that's awful.
God.
My mom had cancer.
She had a fucking shit life, and she had a shit death too, man.
Yep. My grandmother too. Well, actually, my grandmother, she was a fantastic person. But why did she have to? I mean, she had liver cancer, but then she had gallbladder. The whole thing just. It was like, what?
Yeah.
And she was like really loving that everyone loved her and she cared about people and she did anything for people. Like, why that?
Mm-hmm. Mm-hmm. Yeah.
It's life.
Yeah,
it's now part of our makeup that we're getting cancers and shit because of these cosmic rays that zip through our body and destroy cells and turn them against us.
Yeah, and how you deal with your stress.
Yeah, exactly. Yeah. If you keep it inside, bottled up inside, it's going to affect your body. If you let it go, 2 minutes later it's gone, and the other person knows that they did you wrong, and it's all done. I mean, that's the way I am. I flash anger. I show my anger. I show my disdain for what was done, and then I'm back to normal.
Yeah.
Yeah. I don't hold on to things, but.
Shoulder, man.
I don't hold grudges unless it's a repeat offender. Then I just say, I walk away.
That's a shame on you if you're it's like I look at myself. Why is this happening? Because I'm letting them do it.
Yeah, just tell them to get stuffed and walk away.
Yeah, allowing them to be in my life in the first place. And some people are, hard to get rid of or turn your back on to. Oh, well.
I can't wait. I cannot wait until they document that whole 8 miles of that South American rock wall with all of those petroglyphs. I'm going to lay you odds that that is a documentation of what happened. Maybe from day to day, week to week, I don't know, but it's a documentation of what happened all along there.
What? Okay, where have I been?
There's an 8 mile, last year. It was the news broke that they discovered a wall of rock painted in red ochre that shows petroglyphs for 8 miles long, all along this wall face.
Wow.
This exposed face. Yeah, wow is right. And we've only had small glimpses of this thing, and it's just amazing. Some of the stuff that is on this wall looks amazingly similar to the stuff that's in North America.
What was I? I always try to keep up with those things too.
Well, Google it, South America, petroglyph rock wall, 8 miles long. It'll come up right at the top of the feed. Yeah, you did.
Oh, you did a show on it?
Yeah, he did. You were probably there watching.
I don't think so. I would remember that. Okay. It's in the Amazonian rainforest. How come I do? I had heard that before. King Arthur's always, I don't know, I've always been interested in that, King Arthur and Camelot. That. And,
there, I threw up a link in the YouTube chat for Daily Mail news showing the wall, parts of it anyway.
How did they just discover this? I don't understand. How can you just discover something that humongous?
Well, it was discovered 3 or 4 years before that.
I say. Oh, wow. And the petroglyphs, I mean, I think that's a language. It's like how, Sanskrit or whatever is language. I think it's a language.
Like Rongo, I think it's a documentation of what happened. That turned into maybe a language.
I mean, they're pictures, but if they have the same kind of reoccurring picture, that picture means something specific.
Exactly, and and then you have to learn how to vocalize it to say to someone else, this is what happened at this time. But everybody that knew the story about this wall, dead and gone. The meaning has been lost.
How could it just undiscovered for? I don't know.
Well, fuck, the Amazon is huge. I mean, maybe a white man has seen this before, but maybe it was never reported, or maybe it was reported and it was, forgotten about, and but they didn't realize that it was so huge. Someone got a report, went and had a look, and they investigated a little further, walked down the wall a little longer, and kept seeing this shit, and it kept going and going, and they went, oh my God, we got something here.
It's got the zigzaggy lines, and then they have the other kind of lines that are like a kind of
plasma discharge channels. Maybe the squiggly line is separating days or events or something. It could be like a separator of time periods or something.
Yeah.
Or it could mean, an event happened here.
An event happened here, and then
yeah. And this is what we saw up in the sky during or before the event, or after the event, or what have you.
There's these big square or rectangles that are just big squares, like.
Yeah, and Raymond explains that a lot of these big squares have stubby feet, stubby hands, a head, and an antennae.
Oh, what?
Well, look at the it's cut off on the first photo with the guy walking by with the camera right up at the top left. But look down 2 photos below that, you can see that blob that's cut off. You can see there's stubby feet, stubby hands sticking out the top, and what looks like a head with antenna maybe, or a point in the center. And then there's a square with dots in it, with like a cross in it, like an X, and then above those there's squares with ziggy-zaggy lines. This may have been how Saturn presented when things went crazy, when it started to break up. It might have looked like that, or the plasma around Saturn or went into a square, or like a pinch. We've seen these shapes in space before too. These square shapes with X's, like.
Yeah.
You know what I mean? Like.
Huh? And I see that there's a lot of those.
Yeah, and it changed over time. And Saturn, if Raymond is correct, broke up, created Jupiter, created all the other planets, or most of the other planets, and we documented it. We watched it from below. We were locked into polar configuration as all of this was happening. And then because of the proximity of them, and we're all going around the sun in the same area, they start giving off charge at each other when they come close. We got the battle of the Titans, the clash of the Titans, and in the Mahabharata, the battle of the gods. And we're describing the events that we saw in the sky to places on the ground. How weird is that? Oh, maybe some of the places on the ground were affected by the battle in the sky. That's why we associated with them with that.
I don't know where I would. I mean, I try to keep up with these things. I just really love kind of stuff. So that's kind of cool that I'm, it's kind of exciting for me because it's like, oh, something new. Wow, this is what I'm going to have to really get into.
It hasn't started yet, man.
Started yet?
No, start until what, 6? Something like that? Who cares?
Yeah, I don't care. I do like the commercials, though. Have you guys seen the commercials with Walter the cat? Oh, great. This guy's cat's name's Walter, and it's just cool. I'm sure they're Super Bowl commercials. Oh, yeah. Yeah. But Walter the cat is, it's just cool. Oh, God, I remember the frogs. Yeah, it's one thing cool about the Super Bowl, though. You can, go to the store and whatever. There's not a lot of people there. Makes some good money. I had never even heard of them. So, really? I didn't know they were. Well, that must suck to be some guy that, that's the team you get put on. It's like, you're not any good. It is. Everything, no matter what it is, about money. fun to watch the Olympics. I'm heavy, you know. I am watching.
It's been used as social salve in this country every Saturday when the lads aren't working. You know, they're out spending the money. You know, and it's between the gambling, the soccer, the drinking, and at night go out to clubs. So, so you know, it's a lot of young men. They don't know anything about their environment or politics or anything, but they can name every player in the first division and how much they got signed for. And well, they kind of live the life through that. If the team gets beat on a Saturday night, they're in a bad mood. In a good mood if they win, and it's just an excuse for being unaware, like just plugging into the same soap every day for 30 years, an hour a day, and what happens at the end of it? Just a waste of time. But yeah, I mean, back in the day when sport was, we were a celebration. It were a time to be off work, and everyone played sport or watched sport, or we watched it on TV, or had some kind of sport involvement right through the community. When I was a little boy, my grandma used to like watching the wrestling. So I can't imagine why she liked the wrestling, but she did. But so you know, and then you get to watch the rugby league as well, and so it goes on. And it's a great thing, but it has been controlled by these people who it's like Colgate toothpaste get hold of the team, and it's just another multinational bunch of guys who are trying to launder some money or do something like that. I don't know what. Seems to be that way. When players are worth like 100 million and things like that, I don't know how that adds up.
Well, I've seen. Yeah, there's 17. There's 17 still watching. That's what it says anyway.
Yeah.
Well, I think I'm going to split boys and girls. I'm going to go and do some World of Tanks. Blow some pixel tanks up. It was nice talking to you guys again. Well,
Nice
roger
one.
that.
I'll stick around as long as you're here. Okay. Roger that.
Later, everybody. Have a good day. Take care.
Bye.
Take care, Shockwave. All right, we're going to play a song or two, and then we're going to get back to another video before we log. Thank you for staying, folks.
Hyperborea, mythical land that fascinated writers of the ancient world. Hyperborea is a location in Greek mythology. The inhabitants of this mythical land are known as Hyperboreans, whom the ancient Greeks believed enjoyed extremely long lives. Hyperborea soon as the clouds were set in motion, the winds breathed mirth and frankincense. The Vedas contain hymns to Agni, which glows from the sky. Its fragrance
I'm having a hard time finding something that'll play. I'll try one more time.
this feeling that I can't get over. The kissing's been like kissing snow. So if you're gonna leave, just hit the door. Don't let me down slow. If you got a man, just let me know. I got good loving to give. Darling, let me know. Don't let me down slow. Get your
I got lucky and found something interesting. So I'm going to hang out for about another half hour. I'm just getting it queued up here. 1 second.
Catch you later.
You're trying to pull my chain. Don't you know it'll turn on its master? Big fish in a little pond, black holes waiting on. You're a recipe for disaster. But just a fail with authority. You sing the song with certainty. Don't put your life on Sunday. It's like you got through with Patty, and Gene and Martha and the flame. We'll all come back to you someday.
Good evening and welcome. I still have stories to put out, so I figured I'd make another space show, not necessarily so, for lack of a better name. What I'd like to do is give you the story that you're not hearing about, and that would be the electric universe. Mainstream cosmologists won't even look at the subject, and it's much to their chagrin, I feel. What kind of a scientist would refuse to look at a major part of the evidence? The answer to that says it all, really. That he's not a true scientist. A true scientist has to be of the utmost integrity. All right, well, I got a few stories here, and I'll be back intermittently to talk about some things. Let's get on with the show. I've geared this work toward those who have not seen the material before. It might seem a bit redundant to those of you that know, like I do, that our universe is electric and 99.999% plasma. I'm hoping that I catch that one person who is having a good day and ready to listen to the truth. A wise man once said, "It's easier to fool someone than it is to convince them that they've been fooled." And I have to agree with that. Sometimes people get downright personal about it. It's everything to do with empirical observation and evidence. Just the facts, ma'am. Fasten your seatbelts. We're taxiing down the runway, about ready to take off. We're fixing to climb.
And away we go!
Number 10, hypervelocity stars. Everyone knows that shooting stars are just meteors entering the atmosphere, right? That was kind of funny. What some people don't know, however, is that real shooting stars exist as well. They're called hypervelocity stars. These big fiery balls of gas rocketing through space at millions of miles per hour on a binary star system. At the center of a galaxy, one of the two partners is consumed, while the other is ejected at high speed. Just try to imagine a huge ball of gas, 4 times the size of our sun, hurtling out from our galaxy at millions of miles per hour. Number 9, planet from hell, Gliese 581c. Scientists have determined that this hell of a planet is the most likely candidate for future colonization, despite the fact the entire planet wants to kill you. This planet orbits a red dwarf star many times smaller than our sun, with a luminosity of only 1.3% of our sun. This means the planet is far closer to its star than we are to ours. Because of this, it is stuck in a state of tidal locking, meaning that one side of the planet is always facing the star, and the other side is always facing away, just like our moon's relationship with Earth. Not quite. The moon and Earth are in sync so well that we never see a different side of it. That's how I understand that. The tidal locking of the planet alone results in some pretty odd features. Stepping out into the star side of the planet, it would immediately melt your face off, whereas standing in the opposite side of the planet, where there is no sun, would freeze you instantly. However, in between the extremes is a small belt where life could theoretically exist. Living on Gliese 581c would have its challenges, though. The star it orbits is a red dwarf, which means that it is at the lower frequency end of our visible spectrum, bathing the entire sky of Gliese 581c in a hellish red color. Another side effect of this is the fact that photosynthesizing plants would have to adapt to the constant bombardment of infrared radiation, rendering them a deep black color. Well, Earth used to go around a red or brown dwarf. That is probably why infrared light is good for you. Just looking at this right here, it increases energy, makes your skin healthier, gets rid of cellulite, speeds up fat loss. improves muscle recovery, improves mood, cognitive function, speed healing from injury, and improves metabolism and hormonal health. That's just that one. I've seen others. There must be something natural about it. There's all kinds of things that is good about infrared light. That wouldn't just be by chance that is the case. There is a theory that says that actually what killed the dinosaurs off was flowering plants. And the gravity change, of course. Once the sun got involved, it changed all the plants, and the ones that the dinosaurs were eating went extinct, and then naturally they went extinct after. Many dinosaurs lived in the Purple Dawn era. That's why they have the big eyes and why they could grow to such ridiculous sizes. But dinosaurs weren't the only ones that got to grow to giant sizes. Humans did too. The gravity seemed to be changing a lot at one time or another. Or it would go for a while and then change again and then change again. I would think it's done changing now, but you never know. That's an interesting thought. Dinosaurs that are known as meat eaters on a meteor. So they were nocturnal. It isn't just for nothing that we have nocturnal creatures. Something had to bring that about. Number 8, the Castor system. Here we have the Castor system as one of the 2 bright stars from the Gemini constellation in our night sky. It has some serious luminosity. This is because the Castor system isn't 1 or 2, but 6 stars, all orbiting around a common central mass. 3 binary star systems orbit each other here. So much for a trinary system being rare, they're probably common too. With 2 hot and bright A-type stars being stuck in the system, as well as 4 M-type red dwarfs. Altogether, though, these 6 stars put out roughly 52.4 times more luminosity than that of our Sun. All right, quiz time. What type of star is the Sun? Okay, time's up. Is it a class M star, a class A star, a class G star? Answer at the end of the show. It's a class G star. Number 7, space raspberries and rum. Let's see what it says. For the last few years, scientists have been studying a dust cloud near the center of our Milky Way galaxy. If there's a God out there, it seems that he decided to get creative. This dust cloud, plasma, named Sagittarius B2, smells of rum and tastes like raspberries. And how would they know that? The gas cloud in question consists largely of ethyl formate, which is known to give raspberries their taste. I see, said the blind man. And rum its distinctive smell. Arr. The large cloud is said to contain 1 billion liters of the stuff, which would be great if it wasn't rendered undrinkable by a pesky particle like propane. Have been studying a dust cloud near the center of our Milky Way galaxy. If there's a God out there, it seems that he decided to get creative. This dust cloud, plasma, named Sagittarius B2, smells of rum and tastes like raspberries. And how would they know that? The gas cloud in question consists largely of ethyl formate, which is known to give raspberries their taste. I see, said the blind man. And rum its distinctive smell. Arr. I'd be a pirate. The large cloud is said to contain 1 billion liters of the stuff, which would be great if it wasn't rendered undrinkable by a pesky particle like propyl cyanide. The creation and distribution of these more complex molecules is still a mystery to scientists, however, so we won't be opening up an intergalactic pub anytime soon. Which reminds me, did you know that the electric force is 1,000 billion times more powerful than gravity, or 10 to the order of 39? Number 6 is a planet of burning ice. I've heard about this one before.
Do you remember Gliese, that hellhole of a star that we visited earlier? We're heading back to the same solar system for this one. Gliese supports a planet made almost entirely out of ice. At 439 degrees Celsius, Gliese 436b is quite simply a burning ice cube. Imagine Hoth from Star Wars. I don't want. Except that it's on fire. The only reason this ice stays solid is because of the huge amount of water present on the planet. The gravity pulls it all in towards the core, keeping the water molecules so densely packed that they cannot evaporate. Number 5, the Diamond Star. 55, Cancri, made entirely out of crystallized diamond, would be priced at $26.9 million. Okay. The huge diamond planet was once a star in a binary system, until its partner began to cannibalize it. However, the star was not able to pull its carbon core away, and carbon is just a ton of heat and pressure away from being a diamond. So at the surface temperature of 1648 degrees Celsius, the conditions are almost perfect. 1/3 of the mass of the planet is said to be pure diamond, whereas Earth is covered in water and abundant in oxygen. This planet is made mainly of graphite diamond, and a few other silicates. The huge gemstone is 2 times the size of Earth and has 8 times the mass, making it a super Earth.
And now, for a word from the electric universe. Rawr.
Is the universe expanding? Maybe not. This is from July 20, 2020. Stars are mainly composed of hydrogen. According to consensus ideas, nuclear reactions are thought to convert that hydrogen into helium, initiating the energetic emission that make life on Earth possible. When temperatures in average stellar cores reach about 100 million Kelvin, helium's kinetic energy is strong enough to overcome electrostatic repulsion. So it fuses into carbon-12 and a so-called triple alpha process. After carbon-12, other exotic fusion reactions are said to occur as a star ages, until finally it reaches a stage where nickel-62 nuclei begin to accumulate. Nickel-62 has the highest binding energy per nucleon of any elements, so it can no longer be fused into heavier elements no matter how hot a star's core might become. The accumulation of this heavy ash essentially halts fusion, so radiative pressure is no longer able to hold back the force of gravity that always wants to crush the star. Suddenly, the star's outer layers catastrophically collapse, rebounding off the core out into space in what astronomers call a supernova explosion. In 1997, Adam Rees and Saul Perlmutter were studying Type 1a supernovae because their rise in luminosity and their subsequent decline are considered predictable in consensus circles. That measurement is a way of determining a supernova's true brightness by calculating the supernova's redshift. They can place it in space-time coordinates and find out how far away it is. When Rees and Perlmutter crunched the numbers from their observations, they were shocked to discover the recessional velocity redshift of the most distant Type 1a supernova indicated that they were accelerating. Not only that, the further away they were, the faster they were speeding up. This effect is called dark energy, because no apparent cosmic influence could be seen. As time went on, new observations by various groups resulted in the conclusion that dark energy makes up 75% of the universe. Dark energy is another of the phantoms that arise when redshift is applied to observations. Redshift has been the bane of astrophysics since Hubble first identified what he thought was the Doppler effect in images of faint galaxies. Instead of seeing redshift as an effect of acceleration and distance, it may be an intrinsic property of matter.
Astronomer Halton Arp proposed that idea many years ago, and it deserves further investigation, especially when anomalous observations are considered. High redshift objects in front of low redshift objects, for example. All of the dark things in astronomy are artifacts of a crackpot model of cosmology, and we're going to be doing a little spotlight on Halton Arp's discovery in a little bit. The dark energy model of the universe demands that eventually all of the stars will disappear, and there will be eternal darkness. In the words of Brian Schmidt, the future of the universe looks very bleak. I think the future for him is bleak. He confirms my portrayal of Big Bang cosmology as hopeless. Wal Thornhill. All right. Then it says Steve Smith, so they must have both wrote this. Gloomily came to the ironic conclusion that if you take a highly intelligent person and give them the best possible elite education, then you will most likely wind up with an academic who is completely impervious to reality. Halton Arp. Seeing Red by Halton Arp. There is now a fashionable set of beliefs regarding the workings of the universe, greatly publicized as the Big Bang, which I believe is wildly incorrect. But in order to enable people to make their own judgments about this question, we need to examine a large number of observations. Observations in science are the primary and final authority. More than 10 years have passed, and in spite of determined opposition, I believe the observational evidence has become overwhelming, and the Big Bang has in reality been toppled. There is now a need to communicate the new observations. The connections between objects and the new insights into the workings of the universe. All the primary obligations of academic science, which has generally tried to suppress or ignore such dissident information. It makes one wonder with profit whether there are other uncertain assumptions on which much of our lives are built, but of which we are incorrectly overconfident. The present book is sure to outrage many academic scientists. Many of my professional friends will be greatly pained. Why then do I write it? First, everyone has to tell the truth as they see it, especially about important things. Integrity. The fact that the majority of professionals are intolerant of even opinions which are discordant makes change a necessity. Those friends of mine who also struggle to get the mainstream of astronomy back on track must feel that presenting evidence and championing new theories is sufficient to cause change, and that it is improper to criticize an enterprise to which they belong and value highly. I disagree. In that I think if we do not understand why science is failing to self-correct, it will not be possible to fix it. At this point, I believe we must look for salvation from the non-specialists, amateurs, and interdisciplinary thinkers, those who form judgments on the general thrust of the evidence, those who are skeptical about any explanation, particularly official ones, and above all, are tolerant of other people's theories. When the complete answer is not known, in a sense, everyone is a crackpot. Gasp. If the cause of these redshifts is misunderstood, then distances can be wrong by factors of 10 to 100. And luminosities and masses will be wrong by factors up to 10,000. We would have a totally erroneous picture of extragalactic space, and be faced with one of the most embarrassing boondoggles of our intellectual history. Because objects in motion in the laboratory or orbiting double stars
or rotating galaxies all show Doppler redshifts to longer wavelengths when they are receding. It has been assumed throughout astronomy that redshifts always and only mean recession velocity. No direct verification of this assumption is possible, and through the years, many contradictions have arisen and been ignored. The evidence presented here is, I hope, convincing because it offers many different proofs of intrinsic non-velocity redshifts in every category of celestial object. It is interesting to note that at first Einstein felt the solution was incorrect. Later, he said it was correct, but of no consequence. Finally, he accepted the validity of this solution, but was so unhappy with the fact that it was not a stable solution, i.e., it either collapsed or expanded, that he retained the cosmological constant he had earlier introduced in order to keep the universe static. This constant was later referred to as the cosmological fudge factor. In 1924, Hubble persuaded the world that the white nebula were really extragalactic, and a few years later announced that the redshifts of their spectral lines increased as they became fainter. This redshift apparent magnitude relation for galaxies became known as the Hubble law, through lack of rigor, often referred to as the redshift distance relation. At this point, Einstein dropped his cosmological constant as a great mistake and adopted the view that his equations had been telling him all along, that the universe was expanding. Thus was born the Big Bang theory, according to which the entire universe was created instantaneously out of nothing 15 billion years ago. This reality is the entirety of the theory on which our whole concept of cosmology has been rested for the last 75 years. It is interesting to note, however, that Hubble, the observer, even up to his final lecture before the Royal Society, always held open the possibility that the redshift did not mean velocity of recession, but might be caused by something else. In his seminal book, Realm of the Nebula, Hubble wrote, "On the other hand, if the interpretation as velocity shifts is abandoned, we find in the redshifts a hitherto unrecognized principle, whose implications are unknown." In the ensuing years, the evidence discussed in the present book has built up to the point where it is clear that the velocity interpretation can now be abandoned in favor of a new principle which stands on a firm observational and theoretical foundation. But of course, the stunning aspect of the Rosat observations was that two quasars of redshift 0.63 and 0.45 are actually physically linked by a luminous connection to a low redshift object of z equals 007. When I showed this to the local experts, they were alarmed. There were alarmed states followed by annoyance. This result made it clear that the compact and interacting groups were just a more concentrated assemble of young, non-equilibrium companion galaxies, which had been ejected more recently from the parent galaxy, and were composed of material of higher redshift. Aside from being empirically true, this interpretation solves all the conventional paradoxes of the failure of the galaxies to merge into a single galaxy on a cosmic timescale, and also explains the unbearable presence of discordant redshifts. In later chapters, do not evolve with smoothly decreasing redshifts, but change in steps. One major point of the present book is to try to make it impossible to ignore the enormous amount of mutually supporting significant evidence, which all points to the same conclusion. In the face of 28 years of accumulated evidence, to go on proclaiming that quasars are out at the edge of the universe seems unpardonable. Altenar. Here is a list, summary alignments quasars, galaxy clusters. Objects which appear young are aligned on either side of eruptive objects. This implies ejection of protogalaxies. 2. The youngest objects appear to have the highest redshifts. This implies that intrinsic redshift decreases as the object ages. 3. As distances from the ejecting central object increases, the quasars increase in brightness and decrease in redshift. This implies that the ejected objects evolve as they travel outward. 4. At about z equals 0.3 and about 400 kpc from that parent galaxy, the quasars appear to become very bright in optical and X-ray luminosity. This implies that there is a transition from BL-LAC objects. There is a transition to BL-LAC objects. Few BL-LAC objects are observed, implying this phase is short-lived. Clusters of galaxies, many of which are strong X-ray sources, end to appear at comparable distances to the BL-LACs from the parent galaxy. This suggests the clusters may be a result of the breaking up of a BL-LAC. 7. Clusters of galaxies in the range of z equals 0.4 to 0.2 contain blue active galaxies. This is implied that they continue to evolve to higher luminosity and lower redshift. 8. Able clusters from z equals 0.01 to 0.2 lie along the ejection lines from galaxies like Sin A. Presumably, they are an evolved product of the ejections. 9. The strings of galaxies which are aligned through the brightest nearby spirals have redshifts z equals 0.01 to 0.2. Presumably, they are the last evolutionary stage of the ejected protogalaxies before they become slightly higher redshift companions of the original ejected galaxies. Okay, Thunderbolts does have one for diamond stars. The diamond fields of the mind. A planet made of compressed carbon is said to be orbiting a neutron star. The star becomes a diamond. A recent press release announced the discovery of a planet in orbit around a pulsar that is thought to have once been a star, but is now a planetary body composed of something similar to compressed carbon or diamond. The reason for the supposed density and composition assumptions is that the planet was seen in an orbit around the pulsar that is deemed impossible to consensus astrophysics. As announced by the Max Planck Institute for Radio Astronomy in Bonn, Germany, pulsar 1719-1438 rotates more than 10,000 times per minute, has a mass about 1.4 times that of our Sun, but is only 20 kilometers in radius. What is it about the planet's orbit that causes the assumption it is crystalline and dense? Pulsars are neutron stars as the second link. As the theory posits, a neutron star comes into being when a star with at least 5 times the mass of the Sun implodes, shredding its outer layers in a supernova. Since the star is no longer able to shield itself against its own immense gravity, with thermonuclear fusion theory, gravitational acceleration theory takes over, pulling all the electrons in the remaining stellar matter into the nuclei. 2 more links. The massive star's original angular momentum remains, so its rotational period can be astonishing. As 1719-1438 attests,
The increase in rotational velocity can be likened to an ice skater's arms stretched out in a slow spin and then pulled in tight, thus increasing the spin rate. Another link. The force is generated when trillions of gigatons spin as fast as a dentist's drill, means that the star ought to burst apart like a cracked flywheel. However, enough mass is added to the theory so that gravity can hold it together, of course. There is thought to be an immense magnetic field surrounding the pulsar that is focused at each pole. Narrow beams of radio waves blast out from the polar cusps, like lighthouse beacons. Whenever the beam intersects Earth, telescopes fitted with gamma-ray radio wave or X-ray detectors can see it. The final theoretical link in the pulsar chain of circumstances is the tidal force theory that would tear apart a companion star or planet if it came too close. Before discussing the nature of the planet in orbit around the pulsar, it should be pointed out that there was no observation of the pulsar. Rather, researchers first found it in 200,000 gigabytes of data obtained from 3 different radio telescopes, analyzed by supercomputers at 3 different computation centers, using customized software. Garbage in, garbage out. Since 1719-1438's pulses and the data were seen to be systematically modulated, the only conclusion their computer models could reach is that a companion planet is in orbit around the pulsar. Astronomers think an original stellar companion gave up most of its material to the pulsar. As theory supposes, this results in a millisecond pulsar with a white dwarf companion. When I think of pulsars, I remember Don Scott's piece on Thunderbolts of the Gods, which was very enlightening indeed. That was just amazing. He made me think of a strobe light, a relaxation oscillator. Who didn't have one in the 70s? That is what controls a strobe light. So it's the same exact thing, probably, just on a much grander scale. Astronomers think an original stellar companion gave up most of its material to the pulsar. As theory supposes, this results in a millisecond pulsar with a white dwarf companion. 1719-1438 and its dwarf partner are thought to be close together. So the companion must be a white dwarf that has lost 99.9% of its original substance, leaving behind what astronomers suggest is a planet-sized carbon and oxygen sphere. Any lighter element constituents would mean the star would be too big to fit the measured orbiting times. Another possibility, one not considered by contemporary astrophysics, is that electrical oscillations are causing the rapid flicker of pulsars. Don Scott, in his book The Electric Sky, stresses that neutron stars are impossible phantoms, suggesting instead that there is an electrical explanation for their periodic pulsing. He proposes that pulsars are relaxation oscillators. Their pulse frequencies are not mechanical. Instead, it is the capacitive, resistive, and inductive electrical environment around the star. Compacted matter and extreme rotation are not necessary. Electricity traveling through circuits provides a coherent explanation that is consistent with commonly accepted electromagnetic theories, as well as with laboratory experiments. And that's the wonderful thing. Electricity and plasma, you can have tiny little experiments and you can just keep going out to massive galaxies. That is wonderful. When the focus shifts from gravity and gas toward the electrical behavior of an entire system, then steps can be taken that will help to quantify the absolute current density in that system, as well as the capacitive and resistive values, and the magnetic fields generated by the inductive interaction of the binary pair. There must be an electric current generating the immense magnetic fields in a pulsar. It is also indisputable that the feeder current must be part of a circuit, since persistent electric current must complete a circuit. That circuit includes the galaxy in which stars reside, along with all the other galaxies associated with their clusters. Pulsar oscillations are most likely complex in their origins. Steve Smith. Indeed, yes. And that, it's just impossible that they recently found 10 to the 18th amps raw electric current in space, and it doesn't faze them. I just don't get it. Well, I do, but what that comes with is I don't want to believe. It's mind-boggling to me. It's got to be more like they're not allowed to. Couldn't find anything else from the top 10. And back to the top 10. Number 4, the Himiko cloud. If there has ever been any object that has shown us origins of a primordial galaxy, this is it.
the Himiko cloud. The Himiko cloud is the most massive object ever found in the early universe, and it dates to only 800 million years after the Big Bang. Oh, damn, close. The Himiko cloud astounds scientists with its sheer size, roughly half that of our Milky Way galaxy. Himiko belongs to what is known as the reionization, an electrical term, or the period from around 200 million to 1 billion years after the Big Bang. It's the first glimpse scientists have managed to get of the early formation of galaxies. To make it even cooler, it has been introduced as the giant mystery blob discovered near the dawn of time by Space.com. The Himiko cloud, huh? It's interesting. And number 3, the universe's largest water reservoir. 12 billion light years away, the universe's largest water reservoir resides in the heart of a quasar, containing 140 trillion times the amount of water in Earth's ocean, and found near the colossal black hole at the center of the quasar. The water, unfortunately, manifests itself in the form of a massive cloud of gas. Just, wow, 1,000 trillion suns! Not to keep harping on thunderbolts of the gods, but there's a spot in there where a gentleman, I don't know his name, he says that astronomers are looking through the wrong end of the telescope and describing what they imagine they see. I think that is a very good way to sum it up. Number 2, the universe's largest electrical current. And I kid you not, I was just mentioning this. Only a few years ago, scientists stumbled upon an electrical current of cosmic proportions. 10 to the 18th amps, or roughly 1 trillion lightning bolts. What kind of power? The lightning is thought to originate from an enormous black hole. Of course it does. In the center of the galaxy, which has a core that is supposedly a huge cosmic jet that sprays big bubbles. Apparently, the black hole's huge magnetic field allows it to fire up this lightning bolt through gas and dust. It's over 150,000 light years away, and we thought that our galaxy was big. This single lightning bolt is 1.5 times the size of the Milky Way. All right, we'll get to it. Number 1, the LQG. And this is the last one. This is the number 1 surprising thing in space. Now, you know, of course, going back to the quasars for a minute, Halt and Arp proved that they're attached to Seyfert Galaxy, which I have a spot coming up on later. So, yeah, the Himiko cloud is pretty big, like half the size of our galaxy. What about a structure in space so enormous that it breaks the conventional laws of modern astronomy? The structure, my friends, is the LQG, the Large Quasar Group. Our galaxy, the Milky Way, is only 100,000 light years across. Think about that for a moment. If something happens on the far side of the galaxy, it would take 100,000 years for the light to reach the opposite end. I mean, they don't even really think about that. How could a galaxy function if it was 100,000 years behind itself? Just like with the Earth and the Sun. How could the Earth orbit the Sun where it was 8 minutes ago? That right there kills the standard model, but they just ignore it and keep moving. That means something's just basically wrong with that whole thing, and it always has sounded wrong. Now take the length of time and multiply it by 40,000.
Powerful.
Fitted with gamma ray, radio wave, or X-ray detector thing, probably, just on a much grander scale. Be part of a circuit, since persistent electric current must be, which has a core that is supposedly a huge cosmic jet that sprays big bubbles. Apparently, the black hole's huge magnetic field allows it to fire up this lightning bolt through gas and dust. It's over 150,000 light years away, and we thought that our galaxy was big. This single lightning bolt is 1.5 times the size of the Milky Way. All right, we'll get to it. Number 1, the LQG. And this is the last one. This is the number 1 surprising thing in space. Now, you know, of course, going back to the quasars for a minute, Halt and Arp proved that they're attached to Seyfert Galaxy, which I have a spot coming up on later. So, yeah, the Himiko cloud is pretty big, like half the size of our galaxy. What about a structure in space so enormous that it breaks the conventional laws of modern astronomy? The structure, my friends, is the LQG, the Large Quasar Group. Our galaxy, the Milky Way,
is only 100,000 light years across. Think about that for a moment. If something happens on the far side of the galaxy, it would take 100,000 years for the light to reach the opposite end. I mean, they don't even really think about that. How could a galaxy function if it was 100,000 years behind itself? Just like with the Earth and the Sun. How could the Earth orbit the Sun where it was 8 minutes ago? That right there kills the standard model, but they just ignore it and keep moving. That means something's just basically wrong with that whole thing, and it always has sounded wrong. Now take the length of time and multiply it by 40,000. That's right. The large quasar group is 4 billion light years across. The cluster of 74 quasars actually breaks the rules of standard astrophysics, since the maximum size of any cosmic structure should be only 1.2 billion light years across. What comes to mind with that is something I've heard before. They're looking at a bird 20 feet away from them and imagining 747s on the horizon. Something to that effect. Scientists have absolutely no idea how this huge structure formed, since they had previously only been aware of other clusters of perhaps several hundred million light years across. The gargantuan structure absolutely spits on a certain physical law, which states that when viewed from a distance, the universe would look relatively uniform. This is exactly the type of condescending cosmic structure that looks over at our galaxy and, with a smirk, says cute. Interesting article.
This is not a drill.
You know, many people say Hubble's discovery of the redshift was the most important discovery in the history of cosmology. I have to beg to differ with that, as I'm sure you will too, when you know all of the facts. That's one thing. When you're researching, you really have to learn all the facts. It's hard sometimes because they keep them hidden and suppressed. You're not going to find them on the surface, on, TV or any like History Channel or anything like that. They just won't go there. But they never talk about electricity. And that's something that always bugged me, that I knew that electricity was this immense power that existed in the universe. And I just try to think where we'd be without it. I doubt we'd even be here. But this whole thing with redshift was disproved by Halt and Arp in 1966. And instead of investigating the evidence, they tried to sweep it under the rug. I mean, the mathematicians, as I understand it, took Einstein's equations and ran with them. And Einstein tried to put in, the cosmological constant. And he ended up taking it out thinking it was a mistake. So I have a little something here from Halt and Arp. First, this clip of what I think is at least one of the most important discoveries in the history of the universe by Halt and Arp. That is vitally important information. If you've seen it before, it's always good to get a refresher. I know that I've shown clips from this video before, and at the risk of you getting maybe tired of it, I see it as one of the most important documentaries to be seen by people, because this is completely apart from the electric universe part of it. And let's face it, it's an eye-opener when you see just how academia conducts themselves when challenged by a new discovery. I mean, that should be expected in science. And doing science by consensus or peer review is just, moronic and lazy. So even if they don't agree with that, it's just, to me, a very stark image of what academia is really like. And when people see that, like it did for me, it's going to turn them off. I know Halt and Arp has high hopes here. And eventually he's going to be right. The only thing is, it could take another 100 years, but I doubt it. More data comes in. That one discovery is going to put it over the top, and it's not going to be maybe another decade. That's how I see it. I could be wrong. Once one looks at the evidence, and it doesn't take long to see that the electric universe, if you watch a video or read an article from TBolts, or if you watch this video, or Don Scott, or Wall, or any of those guys, or from the plasma universe that this is a part of, you get cold, hard scientific facts and data, information. When you watch a mainstream video
by many a scientist with new and innovative ideas. Dr. Paid by many a scientist with new and innovative ideas. Dr. Arp was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, Arp is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Super Mahan Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which was probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication, you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down in the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, "Well," he said, "this is just too much, and you're going to have to start looking for another job." And so all I could say to him was, "Well, if you send me that in writing, please send me in writing." And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, "Well, we can't continue to give time to this obviously incorrect and embarrassing research that ARP does." So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time. At that point I considered the situation very carefully, and I figured that the evidence, although a lot more evidence could be gathered and has since been gathered since then, the important thing was not the evidence, because if it was true, come out someday, the important thing was the principle of scientific investigation, whether scientists could follow new lines of investigation and follow up on evidence which apparently contradicted the current theorems and the current paradigms. And I also felt that regardless of what happened to me personally, that this was the important issue, and that I had no choice but to resign on the point of this issue, so that if it developed, which I thought it would, that my line of investigation was correct, that people then in the future would say, "Okay, this was the wrong thing to do, and in the future we're going to have to see that this kind of thing doesn't happen again."
The observers come in now with the belief that we live in a Big Bang universe, and therefore all of their ways of understanding things are tailored to that. And they don't come in with the possibility that our alternative, or any other for that matter, is right, and really do it in an open-minded way. And of course what goes along with that is that observers who would like to test this way find it very hard to get observing time and so on. I mean, this relates to the whole issue of the complete lack of balance in the way the observational programs and the funding are conducted. There's no question about that. I don't think that anybody would argue about it.
If protoquasars ejected from the nucleus of active galaxies themselves evolve into new, younger galaxies, astrophysicists must find experimentally and observationally the mechanisms which describe this phenomenon. One model explains that the protoquasars are ejected, trapped in the galaxy's extreme magnetic field, aligned along the spiral arms, thus explaining the torn, disturbed features often observed in the galactic medium, and the frequent appearance of high redshift companion galaxies attached by filaments to a lower redshift parent galaxy. The other and most frequently observed alignment is when quasars appear to have been directly ejected out of the galaxy's active nucleus along its line of least resistance, creating a field of systematically high to low redshift quasars, or younger to older evolved protogalaxies. This is exemplified in innumerable systems like the one around the galaxy quasar field of NGC 3516. If one disregards the proposed redshift distance to these objects, observation clearly points to ejection as a likely explanation for their close vicinity to the central galaxies around which they are found. These results, though preliminary, are promising developments which may lead the way to new and exciting insights in cosmology.
One of the best and earliest of the really controversial things was a Seafoot galaxy known as NGC 4319, which Chip Arp discovered that it had
Because I recently watched a very good, informative Don Scott lecture and took notes. The best way for me to be able to retain the information is to put it into a video. So I will paraphrase a brief summary of the history of plasma physics. According to Professor Don Scott, who we all respect for having a large wealth of knowledge in the electric universe, he says that the first plasma scientist, if you will, was Benjamin Franklin. He was also the first guy to insert a probe into a plasma. The probe was the kite, plasma was the sky. He actually did that. And I always thought that was an old wives' tale. Who would fly a kite in a thunderstorm? But he actually did do that. He's lucky he didn't get killed. But he was smart. He had the key in a jar, or so I think. He remarked that the sky is electric in 1752. Then, James Clerk Maxwell, with the help of Oliver Heaviside, one of my heroes that I've learned into math equations, he was able to put every electromagnetic effect into math equations, and thus electric theory was born. The next guy to come along is a name that we're all familiar with, Christian Birkeland. And Birkeland was the first person to suggest that the causation of the aurora borealis was coming from the sun. He was severely ridiculed for this by this guy Chapman, who was another one of those gas bags who believes in his own image. Chapman thought that the Earth was producing them completely within itself, and Birkeland was proven right at the beginning of the space age from a probe which found that the sun and Earth are indeed connected. You will get cosmologists even to this day who think it's not. Then in 1932, Irving Langmuir came along and noticed that plasma mimicked life, the blood cells, so he stole the name and gave it to plasma. American chemist Irving Langmuir. Today is Irving Langmuir's birthday, so it's a good time to remind ourselves of his very illuminating and timeless warning about pathological science. Langmuir was the first industrial scientist to win the Nobel Prize. The prize was awarded to him for pioneering contributions to surface chemistry, although he also did important research in electronics and solution chemistry. He did most of his work during the early part of the 20th century when science, especially physics and chemistry, was advancing at breakneck speed. Not surprisingly, when science advances at breakneck speed, so do its quacks. Langmuir took note of the many cases of fraudulent science published during the previous decades, and in 1953 gave a talk about the misuses of science, which he titled Pathological Science. His basic definition of pathological science was science which tricked people into believing false results by subjective effects, quantum, wishful thinking, and threshold interactions. Not all pathological science is willfully fraudulent, but all of it suffers from a common set of pitfalls that distinguish it from solid science. One can recognize how prescient Langmuir's talk was by the fact that many of the criteria we use today for evaluating scientific results or progress and identifying scientific misconduct are elaborations of his theses. Indeed. I mean, he knew. I bet he knew a lot of things, like the electric workings of the universe. I bet he had a good idea of it. Yeah, interesting that he would write that. I think maybe I'll do a video on him. He looks like a pretty interesting guy. Moving on. You know, like all things that are covered up, there has to be a reason why they do it. You know, what does it mean that Standard Model is covering up the real deal in space? I'm sure it's for a reason. Did you know a magnetic field is more like a fog? Double layers are noisy. Another name that should be recognizable to you, Hans Alfvén. And with him, according to Professor Scott, Alfvén was an electrical engineer working for a Swedish power company. They were having these explosive disasters, and they tasked Alfvén to find out what it was. And he not only found out what it was, but he fixed the problem. It turned out that there was a capacitance going on, rather a plasma phenomenon. And every now and then, it would explode in these high voltage DC direct current transmission lines. Alfvén deduced that these explosions were occurring in a double layer. So, as Professor Scott says, he extrapolated his ideas into the cosmos. And he reasoned out that this is exactly what is happening in something like a coronal mass ejection. Then Tony Peratt, who was able to create a spiral galaxy in a simulation in a supercomputer using nothing but plasma. And then last but not least, a fellow named Winston Bostick actually created a plasma structure that looked exactly like a snakehead, right? And where you get inside, it's even worse. It was designed by this guy here, I think. I don't know his name. But, man, I mean, is that a snakehead or is that a snakehead? Okay. And now you go inside, and this is what it looks like. You got two fangs there, and it looks like you can see the snake's eyes. And it's a snake. And then, that's not done yet. Then you go from that to looking at the Pope looking out on the people going down the snake's stomach. And now, and then just one more thing here. This is a depiction of Jesus at the place. Have you ever, in the snake's mouth, have you ever seen a depiction of Jesus like that coming out of an explosion? It looks like a nuclear explosion. I mean, that whole thing is, okay, maybe someone out there who's Catholic can give me an honest explanation. Maybe it's something I don't know about with Catholics, but I don't know. It's, I don't know what kind of religion has that. It seems evil. I don't know. Maybe it's just me.
To be kind of a prelude to a situation where electricity will disappear in one physical location and reappear in another physical location without anything going on in between. In other words, a true action at a distance. And as far as like the conspiratorial or theory go, I would go so far to say that two properly constructed devices based on Alexanderson's principles, if you have one antenna in San Francisco and you have one in Los Angeles, and everything was tuned up right, that if you were standing in the one in San Francisco, you would be simultaneously standing under the one in Los Angeles as long as the generators were running. That is the
Janice Phillips said
particular technology or engineering, and that's what makes it worth studying.
Could you comment if you wish that the Philadelphia experiment might have been a variation of that?
Well, see, the Philadelphia experiment I don't know about because that's not there. You know what I mean? But yeah, the Philadelphia experiment would have to be, it would be something similar to that, but it'd be more like that integratron. But we're starting to get into that direction. That's what we're starting to get into. What it is what Alexanderson had done, the picture of his patent, well, I'll draw all that out. Alexanderson had done was to figure out a way to make an electric structure that is what's called scalar. In other words, there's no variation in space. If the switch is closed, the thing's turned on, if there's 100,000 volts at one end of the antenna at t equals 0, at the other end of the antenna, the 100,000 volts is still at t equals 0. There's no time delay for the wave to get from one end to the other. It can be completely neutralized. Now, the first place this was done was in a place called Bolinas, California, which is not too far away from here. This was the first full...
Janice Phillips said, oh, Greg turned that thing on.
...to completely neutralize the velocity, because the velocity in the Alexanderson system is engineerable. It has no relation to the velocity of light, other than infinite velocity and the velocity of light are two what would be called poles or zeros in the system. In other words, they're kind of like nodal points where it crosses over from one state to the other.
Janice, what were you talking about turning on? I didn't understand.
So then they would be captured first by Saturn, Neptune, Jupiter, and then they would continue to do
Mysterious radio bursts are buzzing Earth with an unusual rhythm. Mysterious fast radio bursts, known as FRBs, on the other side of the cosmos, has been pinging our telescopes with a strange cadence. It's probably not aliens, says astronomers. The USA Today reports
Janice Phillips said, "Oh, the thing that reads my comments when you're live."
Helped to pinpoint the location of the repeating signal in 2019. Fast radio bursts, strange, sometimes repeating signals from the other side of the cosmos, remain one of the universe's great mystery. Detectors on Earth pick up these signals, and then in a flash, they're gone forever. And astronomers aren't sure where they come from. But as the amount of radio bursts discovered continue to stack up, astronomers are beginning to discover more and more about them. The fast radio burst FRB 180916.J0158+65, discovered in 2018 and pinpointed to a spiral galaxy approximately 500 million light years away, was examined over a period of 13 months and found to repeat with a highly regular rhythm. The first time astronomers have seen a deep space signal act in such a way. In a new paper published on the preprint server ARXIV and yet to be peer-reviewed, scientists working with the Canadian Hydrogen Intensity Mapping Experiment Fast Radio Burst CHIME FRB project describe a process of listening to the burst between September 2018 and October 2019 using the huge ground-based CHIME telescope situated in British Columbia, Canada. Researchers detected the deep space signals with a startling regularity. Over 4 days, they detected the fast bursts every hour or so, before the signals suddenly stopped. Then, after 12 days of silence, they'd kick back up again, pinging the CHIME telescope. The first FRB was discovered in 2007, but in recent years, new telescopes and in greater interest have seen a motherlode of FRBs discovered. Many of these ultra-powerful radio signals do not repeat. We hear them and they disappear. A small proportion do continue to buzz Earth. In 2019, the CHIME collaboration discovered a new set of 8 repeating bursts for follow-up analysis. It's hoped by studying the repeating bursts, astronomers will be able to shed light on these mysterious signals. And I know what you're thinking, but you can stop right now. It's very, very unlikely to be aliens, says Adam Deller, an astrophysicist. Well, that's his first mistake. At Swinburne University of Technology, aptly named, said, "I think, in all likelihood, we'll work out a natural explanation for these events, keep an open mind, and follow wherever the evidence leads me." I should have a laughing track there. When do they ever follow the evidence? And this was published February the 11th. Now they're saying there has been an update that has transpired on this. Astronomical mystery deepens after fast radio burst detected from unknown source. Image of the host, galaxy FRB 180916 Center, acquired with the 8-meter Gemini North Telescope of NSF's OIR lab in Hawaii's Manatika. The position of the FRB in the spiral arm of the galaxy is marked by the green circle. Astronomers have pinpointed the origin of a repeating fast radio burst to a nearby spiral galaxy, challenging theories on the unknown source pulses. Observations with the 8-meter Gemini North Telescope, a program of the NSF's National Optical Infrared Astronomy Research Laboratory, have allowed astronomers to pinpoint the location of a fast radio burst in a nearby galaxy, making it the closest known example to Earth and only the second repeating burst since Earth's source to have its location pinpointed in the sky. The source of this burst of radio waves is located in the environment radically different from that seen in previous studies. This discovery challenges Daniel Mueller was thrilled, called it picture perfect. His NASA counterpart, scientist Holly Gilbert, exclaimed one word: wildly powerful, and not coming from the edge of the universe, as previously written. Plasma discharges in the form of exploding double layers can accelerate particles in ways that are unfamiliar to consensus astrophysicists. Consensus, that's interesting. Plasma physicist and Nobel laureate Dr. Hans Elfane thought that exploding double layers should be considered a new class of celestial object. Electricity is responsible for stellar and galactic behaviors, and when the current density gets too high, double layers in those circuits catastrophically release their excess energy, appearing as FRBs, X-rays, or flares of ultraviolet light. Elfane wrote, "A study of how a number of the most used textbooks in astrophysics treat important concepts like double layers, critical velocity, pinch effects, and circuits is made. It is found that students using these textbooks remain essentially ignorant of even the existence of these, in spite of the fact that some of them have been well known for half a century, e.g., double layers, Langmuir, 1929 pinch effect, Bennett, 1934. If correct, FRBs are actually nearby, so are less energetic. Plasma is the correct way to interpret their behavior, but it is exploding double layers that impel them. Rather than relying on mathematical phantoms like black holes, why not create real testable hypotheses and work them up with real physical models? Perhaps FRBs are really flashes of cosmic lightning erupting from electrified clouds of plasma in an immense scale." Stephen Smith. He goes more into depth here, but they're pretty much the same. But interesting. I mean, when you have to hypothesize gigantic black holes and neutron stars, you have to also hypothesize huge H-bombs blowing up millions of light years away. Astronomers say Earth has a new mini-moon for now. An asteroid has been caught in our planet's gravity, but it'll float away soon. We have a new space neighbor, at least for a while. Astronomers at NASA funded Kettle in the Sky survey spotted an asteroid that's caught in Earth's gravity, but the space agency's Center for Near-Earth Object Studies noted that it's on its way out of our planet's orbit. Earth has a new temporarily captured object, possibly a mini-moon, called 2020 CD3. On the night of February 15th, my Sky Survey teammate Ted Pruney and I found a 20th magnitude object. Big news. Earth has a new temporarily captured object, and there's a little video of it here. We calculated that the asteroid is between 1.9 and 3.5 meters in diameter. So I don't think too much of this. It's the second asteroid that's known to have entered Earth's orbit. The previous one, 2006 RH-120, was also discovered by the CSS and orbited Earth for 18 months over 2006 and 2007. And this one will be leaving too, I guess. Solar orbiter blasts off to capture first look at the sun's poles. I don't think they're going to like what they find. Cape Canaveral, Florida. It was Cape Canaveral, then it was Cape Kennedy. Now they changed it back to Cape Canaveral again. I don't really know the story there. Europe and NASA's solar orbiter rocketed into space Sunday night on an unprecedented mission to capture the first pictures of the sun's elusive poles. We're on our way to the sun. Go Solar Orbiter. Maybe you guys can find out what that little curly Q thing is at the sun's 8 o'clock. We're on the way to the sun. All right. What a name.
Mara Rodriga,
project manager for the European Space Agency. It's a fantastic moment. It's like, well, we're unstoppable. The $1.5 billion spacecraft will join NASA's Parker Solar Probe, launched 1.5 years ago, and coming perilously close to the sun to unveil its secrets. While Solar Orbiter won't venture close enough to penetrate the sun's corona, or crown-like outer atmosphere like Parker. I mean, Parker went right into the corona. It can take that kind of heat. Whoa.
It will maneuver into a unique out-of-plane orbit that will take it over both poles, never photographed before. Together with powerful ground observatories, the Sun's starting space duo will be like an orchestra, according to Gunther Hasinger, the European Space Agency science director. Every instrument plays a different tune, but together they play the Symphony of the Sun. Oh, I like that, Symphony of the Sun. Solar Orbiter was made in Europe, along with 9 science instruments. NASA provided the 10th instrument and arranged the late-night launch from Cape Canaveral. Nearly 1,000 scientists and engineers from across Europe gathered with their U.S. colleagues under a full moon as the United Launch Alliance's Atlas V rocket blasted off, illuminating the sky for miles around. Crowds also jammed nearby roads and beaches. The rocket was visible for up to 4 full minutes after liftoff, a brilliant star piercing the night sky. Europe's project scientist Daniel Mueller was thrilled, called it picture perfect. His NASA counterpart, scientist Holly Gilbert, exclaimed one word: wow. NASA declared success 1.5 hours later once the Solar Orbiter's solar wings were unfurled. Solar Orbiter, a boxy 4,000-pound spacecraft with spindly instruments, booms, and antennas, will swing past Venus in December and again next year, and then past Earth using the planet's gravity to alter its path. The full science operations will begin in late 2021. Man, I can't believe it's in 2020 already. It's insane. With the first close solar encounter in 2022 and more every 6 months. At its closest approach, Solar Orbiter will come within 26 million miles, 42 million kilometers of the Sun, well within the orbit of Mercury. Parker Solar Probe, by contrast, has already passed within 11.6 million miles, 18.6 million kilometers of the Sun, an all-time record, and is shooting for a slim gap of 4 million miles, 6 million kilometers, by 2025. But it's flying nowhere near the poles. That's where Solar Orbiter will shine. The Sun's poles are pockmarked with dark, constantly shifting coronal holes. They're hubs for the Sun's magnetic field, flipping polarity every 11 years. Solar Orbiter's head-on views should finally yield a full 3D view of the Sun. Well, we're going to see some sweet pictures from that. 93 million miles, 150 million kilometers from our home planet. And it says, with Solar Observatory looking right down the poles, we'll be able to see these huge coronal hole structures. Yeah, maybe you'll get to find out it's electric too, said Nicola Fox, director of NASA's Heliophysics Division. I wonder if it was named after Tesla. That's where all the fast solar wind comes from. It really is a completely different view. I can't wait. To protect the sensitive instruments from the sun's blistering heat, engineers devised a heat shield with an outer black coating made of burned bone, charcoal, similar to what was used in prehistoric cave paintings. You can't burn something that's burnt. That's true. The 10-foot by 8-foot, 3-meter by 2.4-meter heat shield is just 15 inches, 38 centimeters thick, and made of titanium foil with gaps in between to shed heat. It can withstand temperatures of nearly 1,000 degrees Fahrenheit. 530 degrees Celsius. Embedded in the heat shield are 5 peepholes of varying size that will stay open just long enough for the science instruments to take measurements in X-ray, ultraviolet, visible, and other wavelengths. The observations will shed light on other stars, providing clues as to the potential habitability of worlds in other solar systems. Closer to home, the findings will help scientists better predict space weather, which can disrupt communications. We need to know how the sun affects the local environment here on Earth, and also Mars and the Moon when we move there, said Ian Walters. I just have a feeling I'll never do that. Project manager for Airbus Defense and Space, which designed and built the spacecraft. We've been lucky so far the past 150 years, since a colossal solar storm last hit. We need to predict that. We just can't wait for it to happen. Yeah, we'll lose our entire electric grid. The U.S.-European Ulysses spacecraft launched in 1990 and flew over the sun's poles, but from farther afield and with no cameras on board. It's been silent for more than a decade. Wow. And geez, it was launched in 1990? Holy smokes. It's kind of crazy, but it's been out there and hasn't worked yet. Europe, what are they waiting for? Europe and NASA's SOHO spacecraft. Okay, yeah, now SOHO I know about. That's a pretty good one. Launched in 95, is still sending back valuable solar data. Yeah, it's a lot of crazy pictures. So much science still yet to do, she said. Oh, I thought they were near the end. and definitely a great time to be a heliophysicist. And then the electric universe front. Electrical engineering Dr. Donald Scott began his analysis. Some of the most intriguing early findings, including the probes for this new probe here, the Parker probe, unexpected detection of magnetic reversals as it has moved through the plasma solar environment. As Dr. Scott continues, man, it's wild that they got a probe. Egypt shock. Dead Sea Scroll scans suggest Noah's Ark was the Great Pyramid of Giza. And I've heard this before, ancient architects. He has a video about the Great Pyramid. There are miles, a labyrinth of caves and passages underneath it. And a famous artist did made a plaque about it, or a painting on it. I have that. Egypt's Great Pyramid of Giza may have been the metaphorical object used to shield civilization from the Great Flood narrative told in the story of Noah's Ark. A historian has suggested. In the Bible, Noah's Ark is the vessel used in the Genesis flood story through which God spares Noah, his family, and a selection of the world's animals from a world-ending disaster. And most people assumed the story referred to an actual worldwide event with the Ark as a ship. And Matthew Simpson has put forward a theory that the story actually retold a great flood in the Middle East, where Egypt's high rankers used the Great Pyramid of Giza to shield from the disaster. And they used the Great Pyramid as a source for many things, and one of them was a water purifier, which, when you think about it, that's what they would need the most of, would be water and air. But the Great Pyramid exposed after a tiny robot explores mystery shaft. And I'll put the video in the description from Ancient Architects where he surmises the same thing. Mr. Simpson's theory is based on a bombshell discovery in 2016. He revealed on his YouTube, our Ancient Architects. Okay, yeah, this is the guy. I'll be damned, he got himself a little press. That's cool. He said last week the Dead Sea Scrolls were discovered by Bedouin shepherds more than 50 years ago in the Qumran Caves, the Judea Desert of the West Bank, near the Dead Sea. Yes, the Dead Sea Scrolls and the other one, the Nag Hammadi texts, were found 2 years apart. The find contained around 800 manuscripts, thought to be around 2,000 years old, and contain a range of biblical and non-biblical stories, offering experts a glimpse into the past. Some have called it the greatest archaeological discovery of the 20th century. I believe Nag Hammadi was probably even more of a great find than the Dead Sea Scrolls were. But scientists working at the Leon Levy Dead Sea Scrolls Digital Library project scanned tens of thousands of fragments of the scrolls with a custom-made camera that used different wavelengths of light at 28 times higher resolution than standard scans. And it's got some pictures here. Previously illegible words could now be read. Before then, regarding the story of Noah's Ark, scholars had been unable to read a particular word following the Hebrew phrase, the ark's tallness, but the new scans revealed the word Nazfat. The translation of this word from Hebrew to English means gathered, which Dr. Alexei Yudisky from the Hebrew University of Jerusalem says means that the ark's ribs were gathered at the top to form a shape of a pyramid. But there is more evidence of the Ark being described as a pyramid. Mr. Simpson revealed, he added, according to Dr. Yudisky, the Septuagint, a Greek translation of the Old Testament, which dates to the 3rd century BC, also describes the Ark as pyramid-shaped, using a Greek verb that also has a similar meaning to gathered. A number of medieval authors, such as Maimonides, also suggested that Noah's Ark was somewhat pyramid-shaped. Many believe that Noah's Ark is just a myth, and some believe it describes a global flood. But it could be the retelling of a story that centers around flooding in the Middle East. The idea of a pyramid-shaped ark, of course, makes us think of ancient Egypt, and we know that Egypt features heavily in the Old Testament. Mr. Simpson said that it is unlikely that there was actually a pyramid-like vessel, but instead the story is a metaphor for how the Egyptians survived the flood. He also pointed out more evidence of his theory. He added, so was Noah's Ark actually an Egyptian pyramid? Reading the specific words of the Old Testament, it would not appear so. And of course, the Egyptian pyramids were not made of wood. But if the story is a retelling of the Great Flood in Egypt, then maybe there is some truth to the idea, which has been lost in translation. There is more evidence. The elaborate bronze doors of the baptistry in Florence, created by Lorenzo Ghiberti. Lorenzo Ghiberti, that's the artist I was talking about, who died in the 15th century. The doors were completed in the early 1400s and show scenes from the Old Testament. One illustrates the period just after the biblical Great Flood, when Noah returns to dry land. Interestingly, Ghiberti depicts the ark as a pyramid. Mr. Simpson finalized his theory with one more point. He said, some scholars say that the Great Pyramid of Egypt was built to reflect the primeval mound that, according to the ancient Egyptian tradition, emerged from the expanse of the primordial waters. Well, we know that as the Axis Mundi, which, the Christmas tree and everything else is based around. And absolutely, it would be a pyramid. This story is not thought to be literal. Could the Great Pyramid have actually been a structure to survive the flood? That's what Velikovsky thought. And it probably doubled or tripled as a water purifier. We could have got electric power from it. Could have did a lot of things. They built that thing so well we couldn't do it even today. Maybe the Egyptian elites built their own primal mountain to escape an impending flood. That's what I've always said. Anyways, click the link in the description and check it out. I don't know if some of you maybe were around a year ago when we were talking about the pyramid. I even read your comments in another video. And we got a lot talked about in that video, in those two videos. I think everything was pretty much brought up. But the whole thing started it, Velikovsky postulating that it was built to sustain a catastrophe. That's why it had 5 roofs. But we expanded on it. How many remember it? The Lycurgus Cup. 1,600-year-old goblet shows a culture that were nanotechnology pioneers. Researchers have finally found out why the jade green cup appears red when lit from behind. And of course, it's giving full credit to the Romans. I highly doubt that. The colorful secret of the 1,600-year-old Roman chalice at the British Museum. Did you notice at the British Museum? Shouldn't it be in a Roman museum? Is the key to a super sensitive new technology that might help diagnose human disease or pinpoint biohazards at security checkpoints. The glass chalice, known as the Lycurgus cup because it bears a scene involving King Lycurgus of Thrace, appears jade green when lit from the front but blood red when lit from behind. There was also a Spartan lawgiver named Lycurgus who lived a lot sooner. A property that puzzled scientists for decades after the museum acquired the cup in the 1950s. Oh, well, maybe they got it by honest means. I figured, they took it in the Middle Ages. Was the mystery wasn't solved until 1990, when researchers in England scrutinized broken fragments under a microscope and discovered that the artisans were nanotechnology pioneers. They'd impregnated the glass with particles of silver and gold, ground down until they were as small as 50 nanometers in diameter, less than 1,000th the size of a grain of table salt. The exact mixture of the precious metals suggests the Romans, or whoever they were, knew what they were doing. An amazing feat, says one of the researchers, archaeologist Ian Freeston of the University College London. Ancient nanotech works something like this. When hit with a light, electrons belonging to the metal flex, vibrate in ways that alter the color depending on the observer's position. Gang Loganloo, an engineer at the University of Illinois at Urbana-Champaign, who has long focused on using nanotechnology to diagnose disease, and his colleagues realized that this effect offered untapped potential. The Romans knew how to make and use nanoparticles for beautiful art.
I never learned the lowdown on it, but I would have thought the cup would have been a lot older.
Pre-Rome. Lou says, we wanted to see if this could have scientific applications. When various fluids filled the cup, Lou suspected they would change how the vibrating electrons in the glass interacted, and thus the color. Today's home pregnancy test exploit a separate nano-based phenomenon to turn a white line pink. Yeah, there's litmus paper too. That don't mean anything. Since the researchers couldn't put liquid into the precious artifact itself, they instead imprinted billions of tiny wells onto a plastic plate about the size of a postage stamp and sprayed the wells with gold or silver nanoparticles, essentially creating an array with billions of ultra-miniature Lycurgus cups. When water, oil, sugar solutions, and salt solutions were poured into the wells, they displayed a range of easy-to-distinguish colors. Green, light green for water, and red for oil, for example. The prototype was 100 times more sensitive to altered levels of salt in solution than current commercial sensors using similar techniques. It may one day make its way into handheld devices for detecting pathogens in samples of saliva or urine, or for thwarting terrorists trying to carry dangerous liquids onto airplanes. The original 4th century AD Lycurgus cup, probably taken out only for special occasion, depicts King Lycurgus ensnared in a tangle of grapevines, presumably for evil acts committed against Dionysus, the Greek god of wine. If inventors manage to develop a new detection tool from this ancient technology, it'll be Lycurgus 200 years ago. Known example to Earth, and only the second repeating burst since Earth's source to have its location pinpointed in the sky. The source of this burst
Good night, folks. I'm sorry, I'm just so tired. I'm gonna go straight to bed. Thank you for coming. I appreciate it. I'll see you next time. I had a great time. Thank you and good night.
Of my days, the sunshine falls like the rain, and I'm trying to find myself, just don't know where to begin. These tears dry my soul, leaves me standing here with this empty hole, and I said to myself, cry me some tears, let all these memories just disappear. fall like the rain. And I'm trying to save myself. Just don't know where to begin. My fear drives my pain, leaves me standing here in the pouring rain. And I said to myself, cry me some tears, let my fears just disappear. Of my days, on the darkest of my days.
The project has arrived.
Well, we've been here before, slamming those doors. It's 4:15 in the morning. All we do now is fight. No, we won't sleep tonight. Yeah, we're dangerous like fire. We should carry a warning. If I tear my heart out, I still feel pain. Whatever I do still feels the same. Act like it's nothing, but tell me now, what were we thinking of? Everything that we had, well, it's gone to waste. Slip a stand in the sunshine, all I see is rain. So I tear my heart out. when you ride out of home and you your daddy said no, I fell for you. No, we won't sleep tonight. It's 4:15. All we do now is fight in the morning.
Thank you.
1,000-pound weight hanging from your neck. The only thing you do is never let her see you sweat. Then again, maybe I'm going about all wrong, 'cause that's when you just try harder. Smell the flower. The part of you doesn't live here anymore. Living short years disguised in long hours. Think it's time to start living for today. That part of you is was gone.